Hello my dear students, how are you all? Welcome back to the channel. So today's agenda is very simple. We have unit test of mathematics on our hand, okay, and agenda is very simple that we're going to completely revise our syllabus, the chapters that we have in our syllabus for unit test in today's session itself, okay. So for that I have taken almost 84 questions. I'm going to discuss all the problems in detail, and of course we'll give you some homeworks also. If you follow these questions properly, I'm telling you, they are thoroughly taken from your question banks, from your NCERT, whether it is miscellaneous or simple exercises, or whether it is your PYQ. So it's a right mix of questions, total of 84 from all the chapters. Are you ready for this? If you are ready to solve these questions, give me a comment right now. Ready, sir? Ready to ace our unit test mathematics? You can just simply type ready, sir. Okay, let's begin with our question number 1, and before that let's see. So what we have, as I said, the chapter that I'm going to cover today, the chapters that I'm going to cover today through the revision, of course we'll have a question based approach. I hope it makes sense to you. We don't have much time to revise all the concepts, so what we're going to do, we'll solve the questions, lot of questions from each chapters to make our concepts clear. Okay, do not worry, you know me very well. Whenever I'm teaching something, I go to very basic level and then I come back to the question level, right? So that will be there. If I irritate you by doing that, this will going to happen in the session today as well. I have to go all the way to basics, then come back to the problem solving. So you can see, as I said, total of 80 plus exactly 84 questions are there. I'm going to solve, and after that you will be very much confident going in your unit test of mathematics, coming from your PYQs, from your NCERT, including miscellaneous sections, and you have PU board question bank also included in these questions. So whatever questions you're going to see right now are taken from these resources. That makes sense. The chapters, if you want to know what chapter I'm going to revise today, starting from chapter number 1, relations and functions. That's my chapter number 1 revision. Okay, then I'll move on to chapter number 2, which is ITF, inverse trigonometric functions. Next I'm going to move on to what? Chapter number 3, which is going to be matrices, and 4 will be determinant, and 5th would be very simple. The last one will be today's topic, C and D, continuity and differentiability. Now if I have missed out any chapter, do not worry. This is not the only session which is going to come for the revision part of mathematics. We still have live classes scheduled for all of you. Yes, so do not worry, we'll give you live classes before your maths examination, and when we come for that live, you can I can take those topics that is not mentioned over here and you want me to cover that. How would I get to know that? You have to leave those chapters name, those concepts name in the comment section. So right now here itself, please let me know what chapters you want me to add, and what chapters and what questions you want me to add in the live sessions. So you let me know. If you give me that requirements in the comment section, I'll come up with the live session for whether it is North Bangalore, South Bangalore. We're going to do that, and of course we'll cover our entire revision of unit test, and we're going to ace it. Our goal is not to get 50%, 60%, 80%. No, we have to get out of out. We want to ace our unit test without any problem, because very simple questions. You'll see that. Let's start with question number 1 from this chapter, relation and function. Are you ready for it? Yes. Question number 1, have a look. So from the relation and function, question number 1 is the relation R in the set 1, 2, 3 given by R1 to 2, 1. What is it? Reflexive, symmetric, transitive and equivalence relation. Sir, that easy? Yes, it is. It's a PYQ. Please check. I have not made this question. It's a PYQ. What is this? Can this be a reflexive relation? Of course not. If this defined on the set 1, 2, 3, reflexive means I should have, for reflexive, I should have what? I should have 1, 1, and then I should have 2, 2, then 3, 3, and then others can come. Okay, but that is it that present in the given relation? Not present, sir. It means simply not reflexive. What about symmetric, sir? Yes, it is there. 1, 2, 2, 1 means symmetric, not a problem. What about transitive, sir? Of course not. 1, 2, 2, 1 means 1, 1 is missing. So our only option which is going to be correct here is option B. For transitive, no, I should have 1, 1 also, right? A, B, B, C, then AC should also be there. So 1, 1 is missing, hence not a transitive relation. So question number 1 was simple or not? You can look at the question and simply write the answer. Done. 1 mark is in your bag. Both the empty relations and universal relation is what? This is a basically a definition based question. Both the empty relation, basically the null relation that we write, and the universal relation is what type of relation? They are called as trivial relation. Option C is correct. It's a definition based Please go through this. A relation R in a set A if each element of A is related to every element of A, okay, is called as what? Again, a definition question. Is called as universal relation. If you want, I can read once again. A relation R in a set A if each element of A is related to every element of A, then R is called what? Every element or each and every element of A related to every other element of A, okay, without any missing each other, then that is called as your universal relation, okay. Question number 4. So that's simple. Yes, that's simple. Quickly we can solve these questions and move on, okay. Let R be a relation in the set N, okay. N means set of natural numbers given by the relation R is A comma B, that's the ordered pair. A comma B is the ordered pair where A is equals to B minus 2. A is equals to B minus 2 and B is more than 6. B is more than 6. Check here. More than 6 means these are the three options. 8 and 7, okay. It means B is more than 6. Now which one is used over here? If I take B as 8, then I will get A as 8 minus 2, which is 6. So my ordered pair is going to become 6 comma 8. If I take B as 7, I'll get A value as 5. Cross check. So your only option which is correct is here C. Okay. From here I'm getting 5 comma 7. Here I'm getting 6 comma 8. So option is 6 comma 8. Option C is correct. Question number 5 now. Question number 5 now. Okay. So sir, you are going very fast. I want to solve the questions. Please do. Please do. Questions are on the screen. If you want, you can pause the video right now and attempt the question from your side first and then come back and continue with the solutions, okay. Question number 5. Consider the non-empty set consisting of children in a family. Relation R is defined in such way: A or B. A is brother of B. A is brother of B, okay. If A is brother of B, does it mean that B is brother of A? B is brother of A. Is it true always? Excuse me. If I have A is brother of B, does it mean that B is brother of A? This is A R B and this is B R A. Let me know. This is not true, sir. Not always. Why? Because B can be a girl, right? B can be a girl. A is brother of B. Okay? B can be a girl. Then can B be a brother of A? No. Of course, they are siblings. They both are, A and B are siblings. But they are not, both boys, right? Not as mentioned as such. So A is brother of B means B can be a girl. Then we can't say B is brother of A. It will become B the sister of A. Okay? So it means if A R B is true, not always B R A also is true. Okay? It means not symmetric. Not symmetric. Okay? So what about transitive, sir? Okay? A R B. This is A R B. This is A R B. True. Let's check B R C now. B R C. What's the meaning of B R C? It means B is brother of C. It means B is brother of C. B is brother of C. Alright. A is a boy, brother of B. B is also a boy, brother of C. What it means? Can I write this as ARC also? A is brother of C. Correct. Now because if A is brother of B, it means A and B are siblings, right? And if B is brother of C means B and C are siblings. Okay? It means A, B, C are siblings. From here what we get? A, B, C are siblings. Right? A, B, C are siblings. And A is a boy, B is brother means B is a boy, and even if the C is a girl or a boy, A, R, C will become A is a brother of C. It can be A is brother of a girl also, C as a girl, or C as a boy. It means this is always true. I hope this is clear, right? If I take the cases over here, from here we get both of these are siblings, but B can be a girl, so not symmetric. But in the case of transitive, if I take ARB and BRC, it explains that A and B are both boys. Boys means of course they can be brothers, they don't have to be sisters, right? So ARB and BRC represents that ABC are siblings, they are sister and brothers, okay? And A is a boy, B is a boy, it means that ARC statement, which means that A is a brother of A is brother of C. It's true. So it means symmetric is not possible, but transitive is okay. So option B will be correct. Transitive but not symmetric, option B is correct. Have a look. Okay. 5 is clear. Was it fun question? Yes, it was. Question number 6 now. Let f defined on the natural numbers as the domain and natural number as the codomain. Fx is given as x square. Now, so if this question is coming your way in, let's say, 2 marker, 3 marker, this is a different approach to solve this question. You have to use x1 and x2, that method you have to use, right? I'll show you that as well. But if this question is coming in the 1 marker, where you don't need the steps. Do you need the steps in 1 marker in MCQs? You do not need the steps in MCQs, only the correct option is required. Then simply use the derivative approach. Use the derivative approach. Okay? You want to check for 1, 1 on 2, right? So simply take this as y equals to x square and differentiate dy by dx. You're going to get this as 2x. You're going to get this as 2x. Can you say this is always positive or always negative? Can you say this is always positive or always negative? You can't say that. You can never say that, okay? Because if x is positive, 2x is positive. If x is negative, 2x is negative. Means there is no single nature of x, okay? There is no single nature of derivative. So we don't have the derivative as either positive or negative. It means not 1, 1. Not 1, 1, okay? We can also use graphs as well, okay? You can also use graphs also. Use the graphical approach if you want to. You'll get the same result. Okay. Basically, it'll go like this, right? You'll get more than 1 point of intersection. That's why not 1, 1. Okay. Great. So this is clear. What about onto? For onto, we have another approach. Try to take x as plus infinity. Okay. Your y should also go to plus infinity. Okay. Put here x value is infinity. In this case, square of a positive number will become again positive number, so infinity only. Okay. If you take x as negative infinity, y should also go to negative infinity. Please check. If you put x value as negative infinity, square will make it another infinity only, but positive. Okay. This will become as plus infinity. Okay. If you put here x value as negative infinity, y comes out as plus infinity. Is it the same? Is this coming as negative infinity? No. It means this condition is not fulfilled. Okay. When you take x value, the second condition over here, when x tends to mass infinity, when x tends to mass infinity, y tends to what? Plus infinity. Okay. The condition, the required condition is very simple. This is condition 1 and condition 2 for onto functions. Okay. Substitute x as plus infinity. Okay. And from there, if you're getting y value as plus infinity, that's okay. Second, you need this also, not only the one, you need both of the statements. Second statement says substitute x as mass infinity this time, and if you get y value as mass infinity, it means it is onto. But in this case, if you put x value as mass infinity, plus put here y mass infinity the square, how much is that going to be? Plus infinity, right? This will go to plus infinity. Of course, there's no equal to sign, because in infinity, in the case of infinity, there is no equal to sign. Okay, so this is plus infinity. Is it following this given two statements? Of course not. Hence, it is not onto. Not onto. Okay. Now, this might looks difficult approach to you, but I'm telling you this is easier, because if the question is changed, no, this step becomes easier. In this case, the other step is better actually. You can take this as y equals to x square, right? So you get x value as root of y. X value as root of y. It means this has to be always positive. Okay. This y has to be always positive. Y has to be more than 0. Whereas this is saying that natural number. But that's why I'm saying this is contradictory, okay? I can take 0 also over here, but not possible in this case. Okay? And if I take the value of y as, let's say, 3, will I get result as natural number? If I take the value of y as 3, root of 3 is how much? 1.732, okay? Where this is codomain is giving me only value of natural numbers, and domain is also natural number, okay? I hope you get it, right? Yeah. So don't worry about this approach right now. This I'm going to give you later. I have questions on this. I'll show you this approach right now after a couple of questions. Okay? Got it? This is clear. So what is the approach? Let me summarize it. Simply find for the 1 part, simply look for derivative. If derivative is giving you plus sign, if derivative is giving you plus sign or minus sign, any of them, not both. Okay? In this case, they're both. X positive means this dy by dx is positive. X negative means dy by dx is negative. So here we don't have a clarity in that, okay? So that's why we are taking not 1 1. But if we had, I'll show you the next question, if we had positive cases, then it means what? It will become simply 1 1 function. Whereas in this case, if you check here, if you have plus infinity as x, y should be the same. If you have x as negative infinity, y should be the same. In this case, actually, even if you take minus infinity, it's coming out as plus infinity for the y value. Hence, it will be not onto. Answer is option number D. Sir, why did you take this much time to explain this question? Too much time, sir. I wanted to explain this thoroughly, okay? So that in the question that you are getting, you should not have any confusion. You still have, don't worry, that will be cleared in this particular question, number 7. Question number 7. Defined on integers, they're asking you, fx equals to xq, choose the correct answer. Choose the correct answer. First of all, let's check for 1 1 on 2. So if y equals to x cube if I have, okay, and you define y dash, what are you going to get? Derivative of x cube, y dash is divided by dx, derivative of x cube will become 3x square. Now you check in this case, 3 is a positive number, x square is positive, square of an n number is positive. It means this is always greater than 0, or it can be equal to 0 also at some time. Basically, it is always increasing in nature. Hence, y is 1 1, y is 1 1, y is 1 1. What about onto, sir? What about onto? So onto also will come. Please check, x is plus infinity. If you put, what happens to y? Y will also go to plus infinity. How come, sir? Plus infinity the whole cube, okay? It will also tend to plus infinity. What about negative infinity, sir? Again, same thing will happen. It will go to negative infinity. If you take the power as 3, no? For negative infinity, again it will become what? Minus sign, right? Multiplying 3 times. So minus into minus becomes negative only. This is correct. But I want to check one thing. They're saying this is not for real number. This is for integers, okay? So if I take this as, 1 second, I want to just cross check one thing. Y equals to x cube if I take, then I get x equals to cube root of y, okay? So if I take y value as 2, y value as 2, okay? Why 2, sir? Because 2 is an integer. Y is from the codomain, right? So 2 is an integer, and I take cube root of that. How much will I get? It will not be a integer. It will be a decimal, okay, or some fraction value. All right. Hence, this will not be this will not belong to integer. Cross check here. So that's why it's very important to cross check also, because here, if this was given from R to R, then question would have been 1 1 on 2. Question would have been 1 1 on 2. But in this case, actually, since it is not R to R, it is Z to Z. It is Z to Z. There's a difference. Please cross check. This is not R to R, it is Z to Z. In that case, I can take a value of y as 2, which is from the codomain. 2 is an integer, okay? But cube root of 2 will not be an integer. Can you find cube root of 2? Can you find cube root of 4? You can't find that. Square root of 4 is there. Cube root of 4 is not possible to find in integer form. If you do that, you'll get not an integer, hence not onto. How come, sir? Please check. The x corresponding to this y value as 2 is not coming out as integer, but x should be integer only, right? X is from the domain, y is from the codomain. Y taken as 2 gives me x which is not an integer. This is 2, okay? Y taken as 2 gives me x as not an integer. It means in those cases, I cannot say always onto. When can we say onto? Whenever we have all the range equal to codomain, but I have some value in codomain which is not giving me a equivalent value in, which is not have any value in the domain, which is not a pre-image of any of the domain, okay, elements in domain. That's why it is not onto. So my answer will become 1 1 but not onto, option C. Can you check here? F is 1 1 but not onto, okay? If it was R to R, then answer will be option A. Be careful. If it was R to R, answer will become option A, okay? But in this case, it is not R to R, is it? No. So my answer will be option C. Option C. Please check. It's a very good question, even for 1 marks, but very, very good question. This also is simple but good question. It says, let A be a set which has n natural numbers 1, 2, 3, 4 till n, and they are asking number of surjections. Okay, number of surjections. So we are defining relation from A to A, right? From A to A. There's a property for this. There's a property for this. You don't have to draw any of this. What is the meaning of surjections? It means none of the elements in A should be left out. Should be left out. And whenever we have this kind of case, no, then function will be 1, 1 also. Whenever you're defining a relation from A to A, okay? If you define a relation from A to A, basically on a set it to itself, then what happens is if the relation is onto, then what will happen? It will be 1, 1 also. That's a property. Try with an example. If it is onto, it will be 1, 1 also. Okay? And what is the meaning of 1, 1? If it is both, means number of bijections. What is the formula for that? Simply n factorial. Simply n factorial. Okay? So number of bijection or number of surjections will be same in this case. That's why the answer will become option B. Option B. They go fast. Since it is relation defined on to itself, set A to itself, okay, then if it is onto, it will become 1, 1 also. 1, 1 onto is a bijection. Number of bijections is defined by n factorial. Answer is B, because that will be same as number of surjections in this case. Please check. Okay. If you want a different approach, you can have this also. For 1 you can have 3 n options. For 2 you have n minus 1 option, like that. If you multiply like this, n times of n minus 1, n minus 2, and go all the way till 1, what do you get? If you want, you can use this logic also. For the first element you have n options, second element you have another n minus 1 option, and so on. If you multiply, you're going to get again result to n factorial, sir. Okay, but I think this method is better. This method is better. Okay. Question number 9. If f is defined from R to R, defined by fx equals to 1 plus x square, then so that neither 1, 1 nor onto. Now in this case, we're going to use method of algebra. Please check. So we'll have here, I can write this as, let's say 2 elements are there, x1 and x2, and I'm writing here f of x1 equals to f of x2. Okay, f of x1 equals to f of x2. If I do that, I get what? 1 plus x1 square equals to 1 plus x2 square. 1 and 1 is cancelled. I get x1 square equals to x2 square. From here I'm getting x1 equals to plus minus x2. Is it possible? Not possible, because for x1 we have two values. If fx1 equals to fx2, it means that I should have x1 equals to x2. In this case we don't have that. It means not 1, 1. Not 1, 1. Basically many 1. Basically many 1. What about onto, sir? Think about it. If I write here y equals to 1 plus x square, what's my range? What's the range over here? Range is always 0 to infinity. 0 to infinity. Okay. What's the codomain? Codomain is given here as all real. Range is not equal to codomain. Okay. Therefore not onto. Not onto. Okay, answer is not 1, 1, not onto. Simple. Let's move on to next question. Question number 10. Question number 10. Prove that the greatest integer function f equals to r to r given by fx equals to gif of x, neither 1, 1 nor onto. Where okay, that's correct. How do you prove it, sir? Please check. If I define this function, have you seen this graph? Yes, this is closed, this is open. Again, this is closed, this is open, closed and open. Here also open, closed, open, close. Number is minus 1, minus 2, 0, 1, 2 and 3. This is also 1, 2. This is minus 1 and minus 2. Okay. So you can see here at every integer there is a gap. Okay. Means before 1 the value of the function is 0. After 1 the value of the function is 1. Again at 2 the value of function is 2. Before 2 it is 1 and after 2 it is again 2. Okay. So if you have to check domain, check the domain. What is the domain, sir? Domain is all real. What about codomain here? The codomain is here, please check. They have given it as R. Codomain is also given as all real. Okay. Whereas the range, check for the range. Range will be what? Simply integers. Any value you put in the, any real number you put in the GIF, output is always integer. Okay. Cross check from here. Are they equal? Simply, sir, range is not equal to codomain. What happens? It means that, this means that not onto, not onto. This is clear. What about 1 function? Do one thing, write f of 1.5. Okay, what is the answer? 1. F of 1.6, what is the answer? Again 1. It means any value you put between two numbers, okay, you'll have the same answer. But in the case of 1, this cannot be the case. Okay, we must have a unique answer for each of the values in domain. Alright, 1.5, 1.6 is the part of the domain or not? Yes, it is. But we have the same value for that, means not unique. Let's check here. So we have f of 1.5 equals to f of 1.6 equals to 1, but 1.5 is not equal to 1.6. Means even though the function value at those 2 points are equal, the point itself are not equal. It means not 1, 1. It means not 1, 1. Function is many 1 into. Not 1 means many 1. This means into. Here's the answer. Please check. Not 1, 1, not onto. Not 1, 1, not onto. Okay, done. Question number 10 is done. Question number 11 now. In each of the following cases, state whether the function is 1, 1 or onto or bijective. Okay, please check this question. 3 minus 4x. So if you check for this first one, how are you going to do it? 3 minus 4x1 equals to 3 minus 4x2. Correct, right? Have a look. 3 and 3 is cancelled. I get minus 4x1 equals to minus 4x2. Minus 4 cancelled. What I get? Basically, I had f of x1 equals to f of x2. This was my first step actually. And from there I got x1 equals to x2. Hence the given function is 1, 1. The given function is 1, 1. What about onto, sir? What about onto? Please check. So it's defined from real number to real number. It's onto only. It's a straight line, right? It's a straight line. Okay. So y equals to 3 minus 4x if you take. Try to find the range from here. So what do you get? You get the value of 4x equals to 3 minus y. So your x value equals to 3 minus y upon 4. What's the y value over here? What's the value of y over here? From here you can check y value is coming out as all real. Okay, 3 minus y has to be, can be any value, right? So y is also all real. Hence it is meaning what? Range is all real, which is equals to codomain also all real. How come this is all real? Think about it. If I write here x equals to 3 minus y by 4 and x is a real number, what value I can take for y? I can take any value for y. I can take any real value for y. I'll get the x as real number. It means y belongs to any real number which is same as codomain. Please check here. This is my codomain, right? Hence it is onto. Therefore, f is onto. 1, 1 onto means that option 1, f is bijective. Bijective. Now for this one I just taught you right now, 1 plus x square. I think somewhere over here. Yeah. Part 2 I've given you already. Part 2 is also done. Okay. Question number 12 now. Question number 12 now. So let f equals to n to n, again natural numbers. Natural numbers. So domain is natural number and codomain is also natural number. Okay. Defined by fn equals to n plus 1 by 2 when n is odd and n by 2 when n is even for all the n belonging to the natural number set. State whether the function is bijective and justify your answer. Okay. So please check. If I take f of 1 belongs to natural number, right? 1 belongs to natural number. So f of 1 is odd. It means I'll have 1 plus 1 by 2. How much is this? 1. Take f of 2. 2 is even, so I have to take this definition. Okay, I get here 2 by 2, which is 1. I am getting here f of 1 equals to f of 2. F of 1 equals to f of 2, but 1 is not equal to 2. Even though function at 1 and function at 2 values are equal, but 1 and 2 are not equal, therefore f is not 1, 1. Clear or not? Clear? This part is clear. Check the onto now. For this we're gonna do part by part. Y equals to n plus 1 by 2 we're gonna take. Y equals to n plus 1 by 2 we're gonna take and cross multiply. What I get from here? 2y equals to n plus 1. From here I'm getting 2y minus 1 equals to n. 2y minus 1 equals to n. Think about it. Any value of y I take. Y from where? From the codomain. Y from where? From the codomain. For all y belongs to natural number, n also belongs to natural number. How come, sir? Think about it. Even if you take this value of y natural number, means I can take 1. 2 into 1 is how much? 2 minus 1. N will become equal to 1. Okay. So I get any value of y from the natural number set, which is codomain set. I get all the values resulting for the n coming from the a domain set which is natural number. It means this is clear. This is onto. Second case, same way, y equals to n by 2 you're going to take. From here also you're going to get 2y equals to 2y equals to n. In this case also, if you take any value of y as natural number, take any value from the codomain as natural number, you'll also have n as a natural number. You'll have a n also a natural number. Think about it. Take y as 5. Take y as 5. 5 into 2, 10. Is 10 a natural number? Yes, it is. Okay. So any value of y you're going to take from natural number set, you'll have n also as the natural number only. Okay. So you can see from here in both the cases, what do you have? You have onto function justified. So the given answer is not 1 1 but onto. Please check. Not 1 1 but onto. Clear? 12th is done. Question number 13 now. So that R to R defined like this. Okay, this is my codomain. This is my domain actually. And this part here is my codomain. Okay. My codomain is, they look like a codomain. Doesn't look like codomain, sir. Okay. My codomain is minus 1 to 1, okay? Minus codomain is minus 1 to 1 and domain is all real, okay? If I want to write it, domain is all real and codomain is minus 1 to 1. Open actually. Please check, it's an open bracket. Defined by fx equals to x upon 1 plus mod of x. X is all real. Is it 1 2? Okay, we have to show that it is 1 1 on 2. We have to show that it is 1 1 on 2. Have a look. So we're going to start with 1 1 function. We'll start solving and showing it for 1 1 function. Then we'll see for on 2 later. So let's do okay, modulus is there. So for 1 1 we're going to start first. For the case of 1 1. Okay. Now clearly we have more than one options available over here. So if I take two numbers for 1 1, remember we used to take always x1 and x2. If I take both case 1, I take x1 and x2 both more than 0. Then what will happen? I'll have here, let's say I'll try with f of x1 equals to f of x2. I get here x1 upon 1 plus x1 equals to x2 upon 1 plus x2. Okay, cross multiply. So I'll end up with x1 plus x2 x1 equals to x2 plus x2 x1. So this is cancelled. So from here what I'm getting? From here I'm getting x1 equals to x2. x1 equals to x2. Okay. So if I take fx1 equals to f of x2, I'm getting x1 equals to x2. It means the 1 1 condition is fulfilled over here. The condition of 1 1 is fulfilled over here. If you check now the second condition, which is again x1 and x2 is both less than 0. Okay, solve it, you'll have same answer. Solve it, you'll have same approach. Okay, you'll have same as this answer. Okay, this will be same as this answer. You'll have x1 by 1 minus x1. I'll show you. You'll have x1 by 1 minus x1 equals to x2 by 1 minus x2. Solve it, you'll have same result. Solve it this one. Okay, the part 3 is important. Pay your attention. Pay your attention on this side. If I take one as positive and other as negative, x1 positive, x2 negative, okay, just for sake, then it means what? It means x1 is not equal to x2, because one is positive, one is negative. Can they be equal? If I take 2 and minus 2, are they equal? Of course not. One is positive, other is negative, so not equal. So x1 not equals to x2. So if I try, even in this case, if I go with f of x1 equals to f of x2, okay, I'm going to prove that this is wrong. I should have taken not equal to, right? But I'm going to prove, I'm taking here as equal to, and I'm going to later prove it as this statement itself is wrong. Check it out. So I'll have over here x1 is positive, so x1 upon 1 plus x1 and x2 upon 1 minus x2, x2 upon 1 minus x2. Have a look. Cross multiply, I get x1 minus x1 x2, and for this side I get x2 plus x1 x2, x2 plus x1 x2. Do one thing, bring this x2 on this side. So I get x1 minus x2, I'm moving this x2 on this side, equals to, this will come on this side, it will become twice of x1 x2. Have a look. x1 minus x2 equals to 2 times of x1 x2. I hope this is clear and better. Have a look. Moving x1 x2 on this side will become twice, right? So twice of x1 x2. Check this out. If x1 is more than x2, x1 is positive, x2 is negative, it means this side is positive. Please check. If x1 is positive, x2 is negative, means the difference will be a positive number. Think about it. I take x1 as 3, x2 as minus 2. Difference of that is 5. So difference will be positive. But this x1 is positive, x2 is negative. Product will be negative. Product is negative. So the sum is positive, product is negative. Can they be equal? It means this is incorrect. This is incorrect. This statement is incorrect. Hence, whatever we took over here, this has to be not equal to. This has to be not equal to. So we started from x1 not equals to x2. Hence, what we are getting? We are getting here f of x1 not equals to f of x2. Please check. So started with this one, right? So we started with equal to sign, but we are getting this statement is incorrect. LHS is positive, RHS is negative. It means this whole thing is wrong. How can we get this wrong? Because we started with this something wrong. So what was the opposite of this thing? Simply not equal to. That's why I've written here f of x1 is not equal to f of x2. So now you will tell me, first case 1, when they are equal, both positive and they are equal, they are also getting this equal. When they are again both negative and they are equal, we also get the same condition as, if you solve this, you will get the same condition as equal, okay. And here when we are not equal, this is also not equal. It means the function given here is 1, 1. First have a look all of this. I hope this is clear. Okay, now I'm going to write over here. So your function f(x) is actually coming as 1, 1. This is clear. This is clear. Now let's move on to onto. What I have, y equals to x upon 1 plus mod of x. Okay. So again for onto also we'll have two cases. Case 1 will be when x is more than 0. When x is more than 0. Okay. So I get y equals to x upon 1 plus x. Have a look. So from here I'll get y plus xy equals to x. From here what I get? From here I get y equals to x times of 1 minus y. Moving this xy on this side, right? So I get x common, 1 minus y. So I'm getting the value of x as y upon 1 minus y. Y upon 1 minus y. Okay. Second case, case number 2. When x is less than 0, this will become y equals to x upon 1 minus x. Cross multiply, I get y minus xy equals to x. Move on this side, I get y equals to x times of 1 plus y. Hence my x value is nothing but y upon 1 plus y. Y upon 1 plus y. And what is the value of y we have? What's the value of y we have? What is y? Y is the codomain, right? We have this from 1 to minus 1. How can we say that, sir? Have a look. Here, codomain is what? Minus 1 to 1. Sir, it is x. X is the element of this set, not the y value. Okay? Not the variables that it shows that it's from the domain. Don't confuse because here written as x, sir, x is for domain, right? No, x in this case represents the element of the set which is given for codomain. Codomain is given in you, given to you in a, what do you call, in a set filter form, okay? So x is the element of the set of codomain, okay? But what is the codomain value from minus 1 to 1? Real number between minus 1 to 1 is given by what? This only, right? Minus 1 to 1, okay? So can you take minus 1? Of course you can't take that. Can you take minus 1? You can't take that. If you take minus 1 over here, this will become 0. Take here plus 1, it will become 0. That's why it is open. That's why it is open. Any value between that, if you take any value, between that, 0 you can take 0. So if you take y value 0, it will become x as 0. This also is 0. So any value between minus 1 and 1, if you take, you will have x as a real number. Okay. So for all the value of y, for all y between where and where? Between minus 1 open to 1. Okay. X will come out as real number. This is true for both the cases. It means it is onto. It means f is onto. How come we can say that, sir? Because they have given here domain is all real. Domain is all real. Means any value of y from the codomain you take, okay, it will come out as that will give you the value of x as from the domain. That's how you define the onto function, right? Please have a look. Okay. If you want, you can also use this approach. You can use here f of x equals to y, right? If you get this approach also will be correct. So put x value as f of y upon 1 plus y. If you solve this, you're going to get value of y in both the cases. Even if you solve this for this, f of y upon 1 minus y, also if you solve, you get this result only. This is the alternative approach. Alternate method. Alternate method. If you want, you can simply use value of x as y upon 1 plus y or y upon 1 minus y. You'll get the result always as y, hence it will be onto. Hence it will be onto. So please check from the beginning. This is clear, right? 13 is clear. Okay. Question number 14. The number of equivalence relation in the set 1, 2, 3. Okay. So your set where the relation is defined is 1, 2, 3, containing the elements 1, 2 and 2, 1. I want to write equivalence relation, right? It should be equivalence. So first of all, it should be reflexive. We have 1, 1, 2, 2, 3, 3. And we want, let's say, it should have, the relation should have 1, 2, 2, 1. So of course try this. 1, 2, 2, 1. This is equivalence or not? Yes, it is, sir. 1, 2, 2, 1 means it is symmetric, and 1, 2, 2, 1 means if you take the transitive rule, you'll get 1, 1 as the AC. Okay. So this is, sir, equivalence. This is one case. Other case will be all of them. We have only one more case, 1, 1. This will repeat, okay? This whole thing will repeat. 1, 2, 2, 1, and basically you have to write here 1, 3, 3, 1, and 2, 3, 3, 2. This is your only case. Okay. Please check. Because if you take 1, 2, 2, 3, it will become 1, 3, right? It means that I have to take both together. If you are thinking in a way that, sir, why can't we make a relation only with 1, 3 and 3, 1? Let's not make with, sir, 2, 3 and 3, 2. If you want to ignore this, sir, you want to make this later, try this out. If you take 1, 3, 3, 1, no, from here if you take 2, 1 and 1, 3, combine here 2, 1 and 1, 3. 2, 1 and 1, 3 you combine. You'll have to have 2, 3 to make it equivalence, right? Because you're saying that 2, 1 and 1, 3 is there and it is equivalence. It means it has to be transitive also. It means that 2, 1 and 1, 3 has to make 2, 3. But you said 2, 3, we'll remove it, sir. We'll take it separately. So we'll not have any case as such, okay? If you're looking for equivalence relation, no, you have to take them together only. Okay? That's why we have only two relations in this case. We have only two relations in this case. So we have answer option B. So for all those students who are thinking, why not, sir, take this at a time? So we'll get second relation over here, we'll get third relation over here. You'll not get it like this. If you're thinking in a way that, sir, can we remove this and just take this? You can't do that because they're saying this is a must. In the question they've given that this cannot be removed, okay? This has to be there. So if this is present and you take this one, you will not have transitive relation. It means it becomes non-equivalence. If you take these two and remove this, again you'll have 1, 2, 2, 3. It means I'll need 1, 3. If you combine these two, what you'll have? 1, 2, 2, 3 means I need 1, 3. So you need this one also. So the only second relation which can be equivalence has to be the relation of all the possible, ordered pairs. Clear? This is clear, right? Next one. Question number 15 now. Same property I used. If you're defining a relation on itself, okay, then if it is 1, 1, this has to be onto also. If it is onto, this has to be 1, 1 also. If a relation is defined on itself, okay, 1, 2, 3 to 1, 2, 3, then if it is 1, 1, it will be onto also. If it is onto, it will be 1, 1 also. So it means both are true. True and true. Option C is correct. Option C is correct. Okay. 1 is true, 2 is true. Next one. So that the relation R on the set of real numbers R defined by R equals to, okay, the ordered pair is A comma B, A less than B square is, okay, neither reflexive nor symmetric nor transitive. Okay, it means none of the three is possible for this. Try with the first one, reflexive. Okay, try with the reflexive first. Can you think of a number? Okay, I'll think of a number 1 by 2. 1 by 2 comma 1 by 4. 1 by 4, right? So if you check here, 1 by 2 square, 1 by 2 is not actually less than 1 by 4, is it? It's not less than 1 by 4. 1 by 2 is 0.5, 1 by 4 is 0.25. So not less than. Not true. This relation is, so we have not reflexive. Sir, how can you take 1 by 2, sir? I can give you a number, no, where it is possible, sir. Take 2, no, sir. Take 2 and 2 square will become, sir, 4. 2 is less than 4. I have told you, if you are watching my sessions, we don't look for where it is true. We look for the answer where it is not true. Okay? Where it is not true, because we are talking about all real numbers, right? So of course you can't look for all the numbers where it is true. But even if you can look for one possible example where it is not true, means your job is done. Which is easier? As a student in the examination, which is easier? Look for all the correct options or incorrect options? So incorrect options, right? So try to look for incorrect ones. So I've got an example of 1 by 2 where it is not possible. That is easier to find out and relate to. I know it is time consuming, but it has to be like that. There is no other way for it. Next is symmetric. But do not worry, in the examination they will not give you a question which is difficult or impossible to solve. Okay, it will be solvable. Just have to think little bit out of the box, little bit. Okay, do more iterations in your mind than your paper. Okay, so next is symmetric or transitive. Symmetric, symmetric, symmetric. What we can do? Can we take 1, 2? Yeah, 1 comma 2 you take the ordered pair. So we have A or B will give me what? Will give me 1 is less than 2 square. Correct. 1 is 1, 2 square is 4. That is true. Let's take 2, 1, which is nothing but BRA, which is nothing but BRA. Okay. What do you get in this case? 2 is less than 1 square. 2 is less than 1 square. Is it possible? No. 2 is more than 1 square, right? 1 square is 1. So 2 is more than 1 square. It means, again, not symmetric. This also is not symmetric. Okay, not reflexive, not symmetric. Let's move to the last case, which is transitive. Okay, which is transitive case. Case of transitive relation. Example again, we can take 5, 3 and more than 3 square, right? Let's do it over here. Okay, 1.9 magic number, you'll see. Okay, please check. So if you take the combination of 5 and 3 first, okay, what happens? 5 is less than 3 square. How much is that? 9. So of course 5 is less than 9. 5 is less than 9. So this is true. This is true. Next is what? 3 comma 1.9. So 3 is less than 1.9 square. 3 is less than, square of 1.9 is 3.61, right? This is also true. 3 is less than 3.61? Yeah. Last one, combine these two, you get 5 and 1.9. 5 comma 1.9. Do it. I get 5 is less than, again 3.61? Not possible. Is 5 less than 3.61? Not possible, sir. It means not transitive. Not transitive. Not transitive relation. Not transitive relation. All three are proved with the help of examples. Is it clear? Clear now? Okay. So this completes your chapters, relation and function. Now we are moving to the second chapter, which is ITF. Very, very important. Okay. Now, so in the first chapter there is not much theory required. Only the definition of for the relation and function. No. For the chapter of relation and function, you need the definitions. I need difference basically. Definition of this one, most important, equivalence relation, and in this we have 3 branches: reflexive, symmetric and transitive, and also number of functions, number of 1, 1, number of onto, number of bijections. All that is important. If you do all of this, no, so please go and open NCERT. In the summary they have given it, and review this concept from there. But it comes to ITF, no, only thing which you need to remember is of course the formulas that you have, formulas from trigonometry PU1, okay, trigonometry PU1. Again, you can find that in NCERT also. Go visit their website, from there you can download it, okay, if you don't have the NCERT access of PU1 right now, but if you have, please use it. Formula of trigonometry from PU1. Second, domain and range of all 6 ITFs, okay. Third will be quadrant rule to get the angles, sign, positive, negative properly, okay. So you need to know the quadrant rule. Apart from that, yeah, inverse, properties of inverse, okay, properties of inverse. Not right spelling, I'll just change it. These things has to be revised here. You have to follow NCERT, that's more than enough. If you follow NCERT right now, open it right now before starting this next part, no, open and go through that, you'll get properties of inverse, follow that, that's good enough, okay. Okay, next is the principal value branch. So first question, before as I said to you, you need to know all of these things to solve the questions. Is there in the NCERT? Please download it right now. I'm going to teach you all the questions in detail. Wherever the theory is there, I'm going to explain that to you, write the formulas, but you need to know all of them, right? If I miss some, either you leave that questions in the comment section, I'm going to discuss that later, or what you can do is simply revise what I've asked you to do, okay. This was for, again, relation and function, this is for ITF. First question, principal value of branch of cosec inverse of x. Very simple, your answer is option C, right? Just wherever the sign is 19, sign is 0, right? That is sign 0 is 0. Remove that from the domain, you get here. This is minus pi by 2 to pi by 2, except for the value 0 between that. Question number 18, principal value of cosec inverse of minus root 2. Here we will use the property of cosec inverse. Property is cosec inverse of minus x is given as minus cosec inverse of x, okay. So in this question what we will have? Minus cosec inverse of root 2. What is cosec inverse of root 2? Special angles, pi by 4. This is pi by 4, that's my answer. Sir, is it there in the principal value branch? Please check. Minus pi by 2 to pi by 2 except for 0. Is there? No? This is minus 45. This is minus 90. It means it is there. Your answer is option A. Your answer is option A. Okay? Clear? Question number 19 now. Question number 19 now. Principal value of cos inverse of cos 7 pi by 6. Okay? So let's write here cos inverse of cos 7 pi by 6. So cos inverse of, write this as cos of, what is this going to be? You'll have this as pi plus pi by 6, I guess. Have a look. 6 pi plus pi, 7 pi by 6, correct. So this will become what? Cos inverse, quadrant rule will come to picture this here. Third quadrant, right? Pi plus any angle is third quadrant. Cos is negative there. So minus cos pi by 6. Okay. Now the property of cos inverse. Cos inverse of minus x is given as pi minus cos inverse of x. Okay. In this case what we'll have? Cos inverse, sorry, it will be pi minus, right? It will be pi minus, not cos inverse, okay? It will be pi minus cos inverse of cos pi by 6. Cos inverse of cos, they are inverse to each other. Cos inverse and cos are inverse functions. We'll cancel the effect of each other. We'll have pi minus pi by 6. Answer is 6 pi minus pi. How much is that? 5 pi by 6. 5 pi by 6. 5 pi by 6. Answer is option number B. Have a look. So this is the property over here. Wherever I need to, wherever I can, I'll write the theory, do not worry about that. And of course you can ask me in the comment section also. Let me know what you need from me for the revision of your your unit test. I'll come up with the live session. In that I'll discuss everything. Done. Question number 20 now. Sine or tan inverse of x, then what is the value of, okay, what is this value actually? Let's do one thing. I'll take tan inverse of x as theta. Okay, then this becomes what? Sine theta. Okay, from here what I get? I get x value equals to tan theta. It means that if I draw the right angle triangle, this is theta, this is x, this is 1. Correct now? Tan theta means what? Opposite by adjacent, so x by 1. So use the Pythagoras theorem to get this value of hypotenuse. You get what? Square of 1, which is 1, square of x, which is simply x square. Simply x square. What do you want? You want sine theta. You want for sine theta will become opposite by hypotenuse. Got it? Assume tan inverse of x as theta, move tan on that side, we get x as tan theta. Use the right angle triangle to get theta value over here. X is this is 1, x by 1 is simply x. If I take tan inverse of x as theta, means this is nothing but sine theta, right? This is theta, sine theta. How do you find sine theta? Opposite by hypotenuse. It means x upon root of 1 plus x square. Option D is correct. Question number 21 now. Question number 21 now. I am requesting you all to please solve these questions. Okay, you want me to come with the sessions, right? So the output will come only when if you are able to solve all the problems, and that can happen only when you have the class notes. So please join the WhatsApp channel. It's completely for free. All the class notes is given there. You can download from there itself. Okay, in the PDF format you will get, and please solve it from your side first before coming back and checking the answers that I have given to you. I'm making a request. Please do not forget to do this. Question number 21 now. Otherwise my efforts are in vain. If you don't solve the questions, then whatever I do, just watching will not be enough. Okay, it's not a theoretical subject, it's a completely applied numerical based subject, mathematics. You have to solve the problems to be able to solve them in the examination. Even one step you don't know what is happening there, no, you'll not come that easily in the exam. Okay, you'll mug up. If you mug up, things are gone. It has to be understood every step. That's why I go and do all the steps. I can skip a lot of steps, okay, but that will not help you out. It'll get you the right answer but not help you out. I'm here to help you in every possible way, understand how you feel as a student, okay? So please, if I'm giving you something, make the most of it. I understand, things are available for free. You're not able to, okay sir, we'll do it later sir. But don't think like that, okay? If things are available for you, even though it is free, make sure that you are making most useful, for your preparation, okay? So you will do that. I have trust in you, but I just wanted to remind you of that. Question number 21. So set up the value of x if sine inverse of 3x minus 4x cube. Okay, so basically if I take x value as what? X value as sine theta, right? Please check. This will become what? This will become 3 theta. Okay, this will become 3 theta, no? Got it? 3 theta means what? And this output will be between what and what? This will be range, right? This will be minus pi by 2 to pi by 2. Correct, no? This will be minus pi by 2 to pi by 2. I'm talking about 3 sine inverse of x. If this is x is sine theta, it means sine inverse of x will become theta. So this will become 3 theta. Whatever is the output for sine will be between minus pi by 2 to pi by 2. Right or not? Do one thing, take this 3 over here and over here. You get here minus pi by 6 theta pi by 6. What are they asking you? They are asking you range of x. They are asking you where the x will lie in. Okay. So how do you get x from theta? Apply sine on all sides. Okay. If you apply sine on all sides, what are you going to get? Sine of minus pi by 6, sine of theta, and sine of pi by 6. Sine is an increasing function. That's why there is no reversal in the inequality. Okay. If we had cos over here, then this will reverse. It will become greater than. In this case, it's a sine increasing function. That's why there is no need of reversing the inequality. What I get from here? Minus sine pi by 6. What is this going to be? Sine theta is going to be simply x. So right here, x sine pi by 6. That's my answer. I'll simplify for all of you. Minus 1 by 2, excuse me, sine pi over 6 is minus 1 by 2, minus 1 by 2, this is x, this is 1 by 2. Option is D. Option is D. Have a look. Question number 21, option is D. Looks difficult? Is it easy? If you were thinking, sir, in this case, sir, it is actually 3x, so it should be the angle as minus 1 by 3 to 1 by 3. No. Have a look. Okay, this is the correct approach. If you know the right approach, you will not think like this. So what did you say? I'm talking about, let's say if I had an option over here. Let's say I had an option over here as option A, minus 1 by 3 and 1 by 3. I know many of you will actually take that option right. And in examination, no, they actually give that option on purpose to confuse you. They'll give you this option as minus 1 by 3 and 1 by 3. You'll say, sir, this is 3x. No, I'll take this as the right option. It's incorrect, you're going to lose marks. So even though you don't have to do the entire approach properly, but you should know the correct approach in your mind. How things are coming. How are you getting minus 1 by 2 to 1 by 2? But how will you do that? By taking sign on everywhere. Sine of pi by 6 is what? Not 1 by 3, it is minus 1 by 2. Okay, in the case of minus sign, and the plus sign, it is 1 by 2. That's why the answer is minus 1 by 2 to 1 by 2. Simple question, done. 22 now. Question number 22 now. Assertion says domain of fx equals to sine inverse of x plus cos inverse of x. Whenever you have sum of two functions or difference of two functions, the domain becomes intersection of the domain of individual functions. So what did you say right now, sir? I didn't get it. I'll explain again. Whenever you have sum of two functions, difference of two functions, the question like this, then the then your domain of the entire function will become intersection of both the domains. Domain of sine inverse. What's the domain over here? Minus 1 to 1. That's my domain, sir. For cos inverse, minus 1 to 1, sir. That's my domain, sir. Okay. Then of course their domain of sum of these two functions will be what? Will be same, no sir. Will be same only. That's why the answer is minus 1 to 1, and your assertion is correct. Assertion is correct. Look at the reason now. Domain of the function is the set of all possible values for which function will be defined. That's correct. That's the definition of domain. This is the definition of domain, right? So both are true. B. Can a question be simpler than this? Of course not. Question number 23 now. Assertion says one branch of sine inverse of x other than the principal value branch. Very difficult. Draw the graph. Whenever you see a question like this, no, more branches they are giving you. Draw the graph. Graph of sine inverse of x. So you didn't teach this question, no sir. I have taught you this question, sir, in the ITF chapter I was teaching, right? In the Sankalp batch, I taught you how to draw the graph of sine inverse of x. This is between which two numbers? Minus pi by 2 to pi by 2, sir. This is pi by 2. What will be the next one? Pi by 2 to 3 pi by 2. So except for the principal value branch, this is principal value branch, I can also have a sine inverse graph like this, right? So even this is any other branch other than the principal value branch, this is true. This is true. And will this interval be invertible for the sine inverse of x? Yes, invertible function in this case, because if I remove this part, no, it will become 1 1 on 2, right? It will become 1 1 on 2. So even this case also is true. Okay. This is 1 1 on 2 in the given function. It's bijective, hence it is both true. Option D is correct. 24 now. 24 now. 24. Match column 1 with column 2. Range of second inverse is option number 2, right? Please check. I hope you are solving the question by yourself first and then you are watching my video, my given solution. Okay. Range of cosecant inverse will be this. So this is my 3. This will of course be 1. Yeah. So your answer will come 2 3 1 2 3 1 2 3 1. Option C is correct. Have a look. If you know the definitions, if you know the properties, domain and range, your answer is very, very simple to solve in this question. And yes, this kind of question comes. If you see your P by Qs, once in a while this kind of question is repeated. So please make sure that you are actually solving it. Okay. Very important to solve this kind of question. Write in the simplest form of tan inverse of cos x minus sin x cos x plus sin x. Whenever you see that tan inverse is over here, try to make this as tan also. Divide by cos. Divide by cos to make the tans. It will become 1 if you divide by cos. Sin x by cos x will get over here. We will have again 1 and same thing. Sin x by cos x. Simplify now. Tan inverse of 1 minus tan x upon 1 plus tan x. I know you all know the answer for this one, right? This is a formula for tan inverse of pi by 4 minus x. No, I'll write one more step. This one can be written as tan of pi by 4 minus tan of x. You might have forgotten, right? That's what I'm writing here. One is what? Tan of pi by 4. Here also 1 plus tan of pi by 4 into tan of x. One last step. Tan inverse of, formula is there, tan of pi by 4 minus x. Tan inverse of tan, they are inverse of each other, cancels each other out. What's my answer? Pi by 4 minus x. That's my final answer. Pi by 4 minus x. X lies between 0 to pi by 2. Answer is pi by 4 minus x. Have a look. This is clear? Done. 25 is done, 26 now. Prove that cos inverse of 4 by 5 cos inverse of 12 by 13 is cos inverse of 33 by 65. So this kind of question is given in your question bank also. So please go ahead and solve. There are more type of question like this can be asked. So please solve this question. Very, very important. Okay. So take this as angle alpha. Result is always an angle, right? In case of ITF, result is always an angle. So this I have taken as angle alpha and angle beta. Okay. And this is alpha plus beta, right? So I'm going to write this as cos of how come, sir? Because if I take cos inverse, no? If I take cos inverse, I'll get simply alpha plus beta. This is alpha, this is beta. And I have cos inverse over here. So I'm going to find out cos of alpha plus beta and we'll see from there. Please check. From here we have cos alpha cos beta minus sin alpha sin beta. Okay. This is equals to what? Excuse me. This is the value of y actually. So I'll just continue like this. Okay. So I get cos alpha is what? If cos inverse of 4 by 5 is alpha, it means cos alpha is 4 by 5. If cos inverse of 4 by 5 is alpha, it means cos alpha, move on this side, is 4 by 5. This is 4 by 5. And this is what? Again same fashion, 12 by 13. Right? Cos inverse of 12 by 13 is beta, it means cos beta is 12 by 13. What about sine, sir? What about sine? Think about it. If I have a right angle triangle with this as 4 and this is 5, sorry. Oh my god. 4, this is 5, this has to be 3 only, right? So I get this has to be what? Sine will become 3 by 5. Same fashion, if I have another triangle like this with what value? This is 12 and this is 13, then this has to be what? 5, right? How can you say that, sir? These are simple Pythagorean triplets, 5, 4, 3 and 5, 12 and 13. So I get here 5 by 13, okay? Simplify this, the LCM will be always 65, right? Please check. 13 5s are 13 5s are 65 all the time. 4 into 12 is 48. 5 into 3 is 15. What I'm getting over here? 48 minus 15 is 33 by 65. 33 by 65, have a look. Okay. This is 33, okay. 33 by 65. And what we are looking for is, doesn't look like 33. 1 second. Yeah. This is better now. So this was what? This was the value of cos, right? So I can write here cos of alpha plus beta is 33 by 65. Okay. So I can write here alpha plus beta will become equal to cos inverse of 33 by 65. Hence proved. Please check. alpha plus beta equals to cos inverse of 33 by 65. Done or not? Done, sir. Proved. Done. Okay. 27 now. 26 is very simple. 27. Okay. All right. Again, we have to prove one more question with the help of inverse and of course trigonometric formulas. We'll see. We want here cos inverse of x. Let's take x value now as cos theta. As cos theta. X value as cos theta. You'll see the difference. If I do that, I want to show you one thing. 1 plus x actually will become what? Will become cos theta by 2 minus plus, right? Yeah, plus 1 second. 1 plus cos is there, right? Okay, sorry. Yeah. Not that. My bad. So this will be something different. This will be what? 1 plus cos means it will become 2 times of cos square theta by 2. This will become 2 times of cos square theta by 2. So if I take root of this, no? If I take root of this, I'll have here simply root 2 cos theta by 2. Okay? And over here, I'll have minus. Same thing. It's better to write individually, okay? Better to write individually, sir. I'll show you, sir. This will be root 2 cos theta by 2. And if I go same way, 1 minus x, right? I'll have here 2 sine square theta by 2. The formulas, I told you I'm going to write. The formula is very simple, this one. Cos 2 theta equals to 2 cos square theta minus 1. And this is also equals to 1 minus 2 sine square theta. So I'm using this formula, okay? I'm using this formula. Okay? So if you do that, you're going to have over here as root 2 sine theta by 2. Root 2 sine theta by 2. Let's use this expression itself. We have tan inverse. And this will become root 2 can be taken common. And I have over here what? Cos minus sine, right? So cos of theta by 2 minus sine of theta by 2. Okay? And divided by, again we'll have root 2 here. And this time we'll have cos again. So we have here cos of theta by 2 plus sine of theta by 2. I hope this is clear. Because both terms have root 2, right? That's why I've taken root 2 common. Here we have minus sign, here we have plus sign. So I've taken minus and plus. Cancel these two out. Okay? Alright. Let's continue now. What next step will come? I have cos minus sine, cos plus sine. I can use what? Divide by cos to get tan, so that I have tan inverse operated outside. Okay? So let's do one thing. I get here tan inverse, and this will become 1 minus tan theta by 2. I'm dividing everything by cos, right? So this will become 1, this will become sine by cos, which is tan theta by 2, and 1 plus tan theta by 2. Okay? Now I have done this already in the previous question where I took the 1 as pi by 4. Remember, tan pi by 4 I took for 1, and then use the formula of tan inverse of tan of pi by 4 minus theta by 2. In this case I'm going to use directly, okay? In this case I'm going to use directly. I'll write this as the denominator in the bracket part, pi by 4 minus theta by 2. I'm replacing this bracket with this value, tan pi by 4 minus theta by 2. Apply this tan on tan inverse, I get this value as pi by 4 minus theta by 2. Right here pi by 4 as it is, 1 by 2 as it is into theta. What is the value of theta? Cross check. Theta value. If x is cos theta means theta value is cos inverse of x, right here. Cos inverse of x. Please cross check, this is your answer. This is your answer. Pi by 4 minus 1 by 2 cos inverse of x. Pi by 4 minus 1 by 2 cos inverse of x. Okay? I hope this is simple. This is equals to your RHS. Got it? This is your LHS, okay? We got this equals to means we have proven it equal. Okay, 27 is done, 28 now. Question number 28 now. Solve the following equations. Tan 2 tan inverse of cos x, tan inverse of 2 cosec x, and tan inverse of 1 minus x upon 1 plus x. Okay, so I'm going to give you a hint for all the questions. You have to solve from your side wherever last step is required. If not, I'll try to solve it from my side only, but I'll still give you hint for all the questions. Starting from the first one. 2 tan inverse of cos x, right? Okay. 2 tan inverse of cos x will become, there's a formula for that, right? There's a formula for this part. Have a look. The formula is tan inverse of 2 cos x upon 1 minus cos square x. Formula for this part is this. 2 cos x upon 1 minus cos square x equals to the same thing. What is that? Tan inverse of 2 cosec x. 2 cosec x. 2 cosec x. I hope this is visible, okay? I can remove this tan and tan inverse, both sides. They are the same function, operate. How do you remove this? Operating tan on both sides. When you do that, tan of tan inverse will be cancelled. Again, same thing will happen on the other side. What did I say? Operate with tan on both sides, taking tan on both sides, okay? What I get over here? 2 cos x upon sin square x equals to 2 cosec x, okay? 2 and 2 is cancelled. 2 and 2 is cancelled. Take everything on the other side. We'll have over here cos of x equals to cosec x into sin square x, which gives me 1 equals to, this will become sin, right? Please check. So this 2 multiplication will become sin. Sin square into cosec x will become simply sin. Now take this cos x over here, will become in denominator as divided by cos x. This is nothing but what? This is nothing but tan of x equals to 1. This can happen when x is equals to any n pi plus pi by 4. Pi plus pi by 4, if I take n value as 0, n can be 0 also, can be 1 also, and so on. Okay? And tan of pi by 4 is what? 1. It can happen if you have pi plus 4. Pi plus that angle, right? After that third quadrant. That's why I'm writing here n pi plus pi by 4. That's your first answer. Okay? First one doesn't need your help. I've done the question number 1. Question number 28, part 1, done completely. Now part 2. Part 2 of this question. Excuse me. Part 2 says tan inverse of, this is simple, right? Tan inverse of 1 minus x upon 1 plus x equals to half of tan inverse of x. This is a formula, right? We're going to get here as pi by 4 minus tan inverse of x equals to 1 by 2 tan inverse of x. Move on this side, this will become plus, right? So pi by 4 equals to 3 by 2 tan inverse of x. Correct? This is the formula. Tan inverse of 1 minus x becomes tan inverse of 1, basically which is pi by 4 minus tan inverse of x. Right? 1 by 2 tan inverse of x is as it is. Move on this side, becomes plus tan inverse of x. This becomes plus tan inverse of x. Add them, we get 3 by 2 tan inverse of x. Okay? 2 2s are 4. Bring this 3 over here. I get pi by 6 equals to tan inverse of x. Apply tan on both sides. Tan pi by 6 equals to x. It means x value is what? 1 by root 3. Done. Part 2 also is done. Part 1 also done. Part 2 also done. Okay. Part 3 I'll give you a hint, but you have to solve from your side. Okay. 28th, part 3. Have a look. What is the part 3? Tan inverse of 1 minus x equals to what we have? Pi by 2. I can take this on this side, no? So pi by 2 plus 2 sin inverse of x. 2 sin inverse of x. Please have a look. What I've done, I've taken this term on this side, okay? I've taken this term on this side. Alright. Now take sine on both sides. We get here 1 minus x as it is. Sine of pi by 2, this is the third part. Plus 2 sine inverse of x. Okay. So I get here 1 minus x. Sine of pi by 2 plus something will become cos, second quadrant, right? So cos of 2 sine inverse of x. Okay, that's correct. The formula for cos in terms of sine will be 1 minus 2 sine inverse of 2 sine of sine inverse, right? Formula of cos, right? So 2 sine of sine inverse of x, okay, and this whole thing the square. Formula is 1 minus 2 sine square x, okay. So taking the square on over here, I get 1 minus, this will be cancelled, right? I'll have simply x square equals to 1 minus x, 1 and 1 is cancelled, mass cancelled, I get x equals to 2x square. It means value of x is either 0 or what, or 1 by 2, right? Yeah, or 1 by 2, please check. So I think out of this no only one value will be possible. Let me know. For question number 28 part 3, what is the right answer? Okay, so out of the given two values I've given over here, 0 and 1 by 2, only one is correct. So give me the right answer. Now don't give me 0, 1, 0, 1 by 2, sir, like that. Give me only one answer. I want from all of you. And how do you get the right answer? How do you reach the right answer? Put the value of 0 or 1 by 2 in this format. Put x as 0, see if it is true. Put 1 by 2 as x and see if it is true. It will be true only for one option. So I want all of you should give me only one answer. Not 0, 1 by 2 like that, sir. Half of you are saying 0, half of you are saying 1 by 2. I don't want that. Question number 28 part 3, substitute the value of x as 0 or 1 by 2 in the given expression, third one, and give me the result. Okay, 28th is done. Okay, so this completes your chapter ITF also. This completes your chapter ITF also. Again, if I have missed something, if you want me to do some other type of question, what can you do? Leave me the question in the comment section. I will take that in the live session and discuss it over there. And if you want, you can attend the live session and ask me questions directly over there itself. Okay, the matrices over here also, what is important to revise? Basically all of it, but I'll write some of the highlights. Properties, okay, and then will be your matrix multiplication, and of course some questions on operations also. But these are the two highlights of the matrices chapter. These two are the highlights of the matrices chapter, because from here only the students will make mistakes on, you'll see. So please open the NCERT. Again, as I said, NCERT is more than enough for a revision. Open NCERT, go to summary, go to the NCERT summary and revise from there. If you actually have time, go ahead, watch my videos of matrices. They have explained everything in detail. Okay, in Sankalp batch 2026, I have in Sankalp 2026 batch, go check the playlist for matrices chapter, and I've explained you everything in detail over there. But if you still want to, spend some less time and get the summary that is enough for you, then you can find the NCERT summary. That will be too much, actually more than sufficient to solve any question coming in your examination. Okay, this is clear. Now question number 29 for all of you from the chapter of matrices. If a matrix has 18 elements and then the number of matrices having all possible orders, saying 18 elements, right? How do you find that? Remember, 2 into 18, 18, right? Means 1 into 18, right? Possible orders. I mean, it can have 1 row, 18 columns, okay? 1 row, 18 columns. Or you can have 18 rows, 1 column, 2 row, 9 column, 9 row, 2 column, 3 row, 6 column, 6 row, 3 column. These are the possible orders. So 1, 2, 3, 4, 5, 6, total of 6 possible orders are present in this case, where we have 18 elements to fit in a given matrix. Okay, so for the 18 elements to fit in given matrix, I can write in all in 1 row, all in 1 column, 2 rows, 9 column, 9 row, 2 column, 3 row, 6 column, and 6 row, 3 column are my 6 possible orders. Question number 30 now. If a matrix has 13 elements, then the total number of possible matrices of different order are what? 13 elements. Only 2 possible, sir. 1 row, 13 column, and 13 row, 1 column. Only 2 possibilities. Done? Done? Next one. If X is a matrix of order 2 cross n, and Z is a matrix of order 2 cross p. So X is of the order 2 cross n, Z is of the order 2 cross p. They're saying that order of the matrix 7x minus 5z, 7x minus 5z. Okay, we all know that this is possible only when sum or difference of two matrices is possible only when their orders are same. When order of x and z are same. Order of x and z are same. Then only you can add or subtract the two given matrices in any different order, okay, in a different way. So please check if you compare these two. This should also have the same order from what we get here, 2 cross n or 2 cross p. Check the answer. We have only one such option, which is B. Don't take p cross 2 as a difference. P cross 2 is not same as 2 cross p, okay? It's not same as 2 cross p, only when p is also 2. Getting my point? So your answer can be either 2 cross n or 2 cross p, because p and n are equal. P and n are equal. For the difference of two matrices, there must be same order. Okay? 32 now. Which one of the following is not true? Matrix addition is commutative. It's true. Addition is associative. Also true. Matrix multiplication is commutative. Not true. Option C is your incorrect option. Correct choice, but it is an incorrect statement. Okay? So matrix multiplication is not commutative unless until it is inverse. So AB equals to BA only when it is equal to I. Basically, A inverse is B. Only in this case we have multiplication of matrix as commutative. Rest all cases not always. Matrix multiplication is not always commutative. Okay? 32 is done. 33 now. Which one of the following is not true? Correct. Symmetric is A transpose is A. Okay. Skew-symmetric is A transpose is minus A. For any square matrix A with real numbers entries, A plus A transpose is skew-symmetric matrix. Okay. No, this has to be by 2, no? This has to be by 2, this is also has to be by 2. If I want to write this A, no, in terms of symmetric skew-symmetric part, I have to go like this: A plus A transpose by 2 plus A minus A transpose by 2. That's my answer. Okay? That's my answer. This is the symmetric part, this is the skew-symmetric part. Okay? So this is your incorrect choice. So correct choice but incorrect statement. Option C is the incorrect statement but the correct choice. They're not given by 2, right? Have a look. There's a difference over here. So this should be giving by 2 by 2. Okay? 33 is done. It's a close one. If you don't actually follow the properly statement, you might feel that none of them are incorrect actually. In the examination, actually, in your mind, none of the options will look you incorrect. But if you know this statement, how you represent a given matrix in the form of skew-symmetric and symmetric part, using divide by 2 of summation and difference of the matrix and its transpose. Hence, option C is incorrect, sir. 33 is done. 34 now. Statement 1. If A is a symmetric as well as skew-symmetric matrix, then it is null matrix. Correct, no? That is true. A is a symmetric matrix if A transpose is A. Correct? Yeah, correct. They are both true and it explains also. How does it explain, sir? Think about it. If you have A transpose equal to A and also equal to minus A, right? Also equal to minus A, right? It means what? We can say from here that A plus A equal to 0. It means 2A equal to 0. It means what? A equal to 0. Correct, right? So if we have A transpose as A and A transpose as minus A, you can add them. Okay, you can replace A transpose as simply A also. Take this side, minus A on this side, you get 2A as 0. It means A has to be, of course, 0, right? So this statement is true. This also is true. And this second statement explains the first statement. Okay. So answer is true, true, and correct explanation. Option D is correct. True and the correct explanation. Option D is correct. Option D is correct. Please check. 34 is done. Have a look. 34 is done. 35 now. If a matrix A equals to Aij n cross n, match list 1 with list 2. Okay. Scalar matrix. Scalar matrix. This one. Second one. Diagonal has to be constant. Diagonal has to be the same value. I should be equal to j. Okay. Whenever I and j are equal, it should be same value, and when I and j are not equal, it should be 0. Scalar matrix. What it means scalar? It means that let's say it is 2, 2, 0, 0. That's a scalar matrix. Diagonal matrix. For this we'll have 2 and 3 also. Means it need not to be equal. It need not to be equal. Okay. But other has to be 0. So this is going to be, yeah, when not equal, when I and j are not equal, remember A11, A12, Ij represents A11, A12, A21, A22. Check here, A11, A22. It means that I and j are equal. When they are not equal, they have to be 0. That's your definition of diagonal matrix. So 2, 3. This will become automatically 1, 2, 3, 1. Entity is of course 1, 1. Please check. So for entity, you'll have what? 1, 1, 0, 0. Okay. So 2, 3, 1. 2, 3, 1. Option C is correct. 2, 3, 1. 2, 3, 1. Okay. Option C is correct. 35 is done. 36 now. If A is a square matrix of the order n, then adjoint of A determinant is what? Okay, it's a property of actually determinant. This is a Matrices chapter. I think I've taken this question by mistake. All right, forgive me, but answer will know, right? Anyway, we have determinant in our syllabus, so we'll just deal with it over here also. The property is A power, determinant of A power, order minus 1. So what is order over here? Order is n. So n minus 1, and based upon the number of determinant, we'll take the power of that. Based upon the number of determinant, how much is that? In this case, 1. If we have 2, we'll take power 2. If we have power 3, if we have 3 adjoints over here, not determinant, sorry. If we have 3 adjoint over here, let's say we have adjoint of adjoint A, it means we get 3 adjoints. We'll take the power of 3. In this case, we have only 1 adjoint, so power is only 1. Answer is what? Determinant of A power n minus 1. Option A is correct. Option A is correct. 36, option A is right. 37th now. Express 1, 5 minus 1, 2 as the sum of symmetric and skew-symmetric matrix. We can do that. Let's call this to be matrix A. 1, 5 minus 1, 2. First step is to find what? A transpose. First step is to find the A transpose. Do it. Keep diagonal as it is and take this transpose over here. Minus 1 and 5. This is my A transpose. Alright, and we want what? Skew-symmetric part. So do it. We know A equals to A plus A transpose by 2 plus A minus A transpose by 2. We can write directly only, not a problem. What I get? Sum of these two. 2 plus, okay, this is 2. This is 4. This is again 4. This is 4. Okay. Divide by 2 plus difference will make it 0. 6 will make it minus 6, and again 0 divided by 2. Okay, my answer will become A equals to what? Please check. This will become this will be coming as what is it? 1 2 2 2. Okay, plus 0 3 minus 3 and 0. That's my answer. If you add them, you're going to get the answer back to itself. Okay, as matrix A, but you want the sum of symmetric and skew-symmetric part. This is my symmetric part, symmetric matrix, and this is my skew-symmetric matrix. Skew-symmetric matrix. Question number 37 is also over. 37 is done. Please have a look. 38 now. Now, in this case, okay, they were asking you to multiply. I've already solved it so that you'll have, we can save some time while multiplication, but I'll show you every step, don't worry. Okay. So they have given us matrix A 3 cross 3, matrix B 3 cross 3, matrix 3 which is 3 cross 1, and they're asking us to find AC, BC and A plus B times C and cross check whether this is equal or not. What does this mean? This is called as distributive property over multiplication, right? Over addition, sorry. This is distributive property over addition. You're going to multiply C with A and C with B and so whether it is correct or not. Please do it. So how do you find AC? A is over here, C is over here, right? Multiply that. 0 into 2 is 0, 6 into minus 2 is minus 12, 7 into 3 is 21. 21 minus 12 is 9. Answer is 9. Again multiply this second row, minus 6 into 2 is minus 12, 0 into 2 minus 2 is gone. 8 into 3, 24. 24 minus 12 is 12. So this is 12. Okay. Next we have 7 into 2, which is 14, minus 8 into, 7 into 2 is 14, minus 8 into minus 2 is plus 16. So 28, 0 into 3 is gone. So 28 plus 12 will be, 16 plus 14, right? So 30. Answer is, this is 30, sir. This is 30. Okay. Next, again we do for BC. B is here, 0, 1, 1, 1, 0, 2, 1, 2, 0. Multiply with this C again, 2 minus 2, 3. 0 into 2 is gone, 1 into minus 2 is minus 2, 1 into 3 is 3. So we get 3 minus 2 is 1. Same way, multiply this row to column all the time. You get the answer as 1, 8 minus 2. Add them. You want AC plus BC, right? So add them. You get 9 plus 1 is 10, 12 plus 8 is 20, and 30 minus 2 is 28. This is my AC plus BC. What is this? Simply RHS. This is my RHS. Okay. Next time is LHS. So first find A plus B. Add these two. 0 plus 0 is 0. 6 plus 1 is 7. 7 plus 1 is 8. So add this. Very simple. Add the corresponding elements of the matrix. Let's multiply that with C. So writing this over here. C comes from here. 0 into 2 is 0. 7 into minus 2 is minus 14. 8 into 3 is 24. Minus 14 plus 24 is 10. 7 into minus 2 is minus 14. 8 into 3, 24. Add them. 10. Minus 4 into 2 is minus 10. 0 is gone. 30. Minus 10 plus 30 is 20. 20. 8 into 2 is 16. Minus 2 into minus 6 will be again what? 12. So 16 plus 12 is 28. 0 into 3 is 0. 28 is right answer. If you want, you can verify these two are coming same. Okay. This is nothing but your LHS. And we are getting LHS equals to RHS, hence proved. Hence proved. It's a PYQ from March 2023 paper. March 2023 paper. Have a look. Simple question. 38 is done. 39 now. 39 now. This is your homework. This is your homework. You solve and verify this. Okay. Easy, no? Find A plus B, find B minus C, and then check whether this format is correct or not. Okay. What is this format? This is associative law of addition. This is my associative law of addition for given matrices. A plus B. So A plus B minus C and A plus B minus C. Taken B minus C at a time and A plus B at a time. Okay. Do it. Do it and solve it. Very easy question. Okay. And let me know. Comment as question number 39 verified. Okay. Question number 39 verified. It's a very simple question, but it's a PYQ. Please check. It's a PYQ, so write all the steps. Right? All the steps. 40 now. X plus y is given, x minus y is given. They're asking you to find the value of matrix x and y. Do it. Add them. You'll get what? You'll get x plus y plus x minus y. Array matrix. 7 plus 3 is 10. 0 plus 0 is 0. 0 plus 2 is 2. 3 plus 5 is 8. Y and y is cancelled. We get 2x equals to 10, 0, 2, 8. We get x equals to, what is it? 5, 0, 1, 4. X is 5, 0, 1, 4. Find the value of y and comment the answer. Okay. Again, this is also is your homework. So comment matrix y value. Okay. What is the matrix y value? Leave that in the comment section. X I have given you, y value you have to give me. You can do that for me. Come on. X is 5014. Y I am asking you. It's a PYQ. You can solve and give me, right? Yes. 40 is done. 41 now. Question number 41 now. Okay. Now in this question they are saying what? Fx is given. They are saying that so that if you multiply f of x into f of y. What is f of y? In the given matrix, simply replace x as y. I have done that. Simply replace x as y means, check here. This is the same matrix, right? This is the same matrix. Now in the given matrix I have replaced x as y. So I am getting here cos y minus sin y 0, 0, 1 and sin x cos y. What is the next step? To multiply them. Multiply it. Okay. Multiply it. So when you do that, I will not show the entire steps. I will just show you. I will just show you the first row. Okay. Cos x into cos y. First term. Cos into cos y. Next will be what? Minus sin x into this one. So we get here what? Excuse me, cos x cos y. Okay, I forgot to write that. That is incorrect actually. That is incorrect, sir. This has to be y, no? Yeah. I'm writing everywhere x as y, right? So that's why both has to be y only. My mistake. So when you multiply this row to column, what do you get? Cos x cos y, then it will be minus sign. So minus sin x minus sin y. Minus sin y. Okay. 0 with 0 is gone. So this is my first term. This is my first term of the resulting matrix. Next will be what? First row, second column. Cos x into minus sin x. Minus sin y. So I get here minus cos x sin y. And I'll get what? Minus sin x into cos y. Okay. So it'll become what? Again same thing, minus sin x cos y. Sin x cos y. Okay. And then 0 and 0 is gone. And for the last term, please check. For the last term, we'll have cos x into 0, sin x into 0, 0 into 1 is 0. So this will be 0 only. My first, I'm not writing entire thing, just the first row. You have to write the entire thing by yourself. Okay. Think carefully. Cos x cos y, sin x sin y, it becomes simply cos of x plus y, sir. Cos x cos y minus sin x sin y becomes cos of x plus y, sir. Over here. Please check. Take minus sign common. What are you going to get? If you take minus sign common, you're going to get here sin x cos y cos x sin y. Simply sin of x plus y. This is 0. Okay. If you solve, no. If you multiply all the terms, you're going to get here 0, 1. You're going to get here sin of x plus y. You'll have over here cos of x plus y. This will be again 0, 0. Please solve it. Okay. Please solve it. If you do that, you're going to get this term also as x plus y. I got the first two terms. I'm asking you to do two more multiplications. You'll have this term. Okay. Please check. If you compare this with this, what it means? It means simply this is nothing but f of x plus y. Correct, right? In the place of x, if you replace x plus y, won't this become same thing? So what I'm getting? I'm getting f of x into f of y equals to f of x plus y. Please check. Started from here and ending up with this. Done. Question is over. 41 is over. Looks difficult, challenging, scary, but is it difficult, challenging, scary? Not at all. Very simple question. Just had few very basic steps of multiplication. If you do that right, you'll get the result of the formula if you have to use, of course, for trigonometry. And from there, you can see that we are getting the RHS also. We are getting the RHS from here. Clear? 41 is done. 42 now. A is given. Okay. Matrix A is what? Matrix A is 2 cross 3. Matrix B is given as 3 cross 2. What are they asking? Find AB, BA, and so that AB not equal to BA. These two you're going to do. This is homework. Finding multiplication is your work. Okay. I've taught you how to multiply. Please do it. Find AB and BA. Homework. Okay. I'll show you why AB and BA not equal. Find AB. Multiply A into B. What's the result? 2 cross 3 to 3 cross 2. Answer is 2 cross 2 matrix. Multiply B into A. Write B first. B is here 3 cross 2. A is here 2 cross 3. Multiply them. What's the answer? 3 cross 3. Can AB be equal to BA? Never. Because this is 2 cross 2 matrix, this is 3 cross 3 matrix. Never equal. Never equal. 42 is done. 43 now. Right? So 42 is done. Simple, right? 42. You're going to solve this now. A, B, B, you can find it, right? From your side. Not a difficult task to take care of. AB is this. BA is this. Do it. Okay. Multiply AB and BA and get me the result. Alright. Okay. 43 now. Cos alpha, sin alpha. Again they're asking you what? A plus A transpose. Find A transpose. You'll have this cos alpha as it is. This also cos alpha as it is. And this will become what? Sin alpha and minus sin alpha. Add them. So you'll have this as A plus A transpose will become what? Twice of cos alpha 0, 0, again twice of cos alpha. This is equals to what? I. It means 1 0 0 1. Identity matrix means 1 0 0 1. Compare now. 2 cos alpha is 1. Compare these two. 2 cos alpha is 1. It means cos alpha is 1 by 2. It means alpha is pi by 3. Option D is correct. Option D is correct. Option D is correct. 44 now. Again, this is the homework. I have taught you this. Find A plus A transpose, A minus A transpose if they have given you value of A, and check whether it is coming as symmetric and skew-symmetric or not. How do you check for symmetric? Simply A, and A dash should be equal to basically minus A. In this particular case, how are you going to solve it? So you'll have Aij equals to Aji, and you'll have Aij equals to minus Aji. Okay. If you're talking about elemental wise, no, this is the definition of symmetric matrix. But if you want to talk about elemental wise, that's how you're going to deal with it. Okay. Element becomes negative if you reverse the Ij and Ji. 44 is homework. Please solve and let me know. So comment verified, sir. Comment question number 44 verified. Okay. I'm telling you, if you watch this entire video, solve this entire all these questions comfortably, means you are gonna get out marks in your unit test from these chapters if the questions are coming from. Okay, that's a promise. All right, but you have to solve all the questions. You have to be very much comfortable in all the questions. That has to be the case. Okay, trust me on this. If you are solving all the questions, that's more than enough. 44 is done. 45 now. Please put some effort from your side. Okay, prove inverse of a square matrix is, if it exists, it's always unique. It's always unique, means for one matrix you cannot have two inverses. I'm going to do the difference. I'm going to take this as, let's say there is a matrix A, and for this I have B and C as inverse. Okay, I am saying that I'm taking a contradiction over here. For a matrix A I have two inverse B and C. Yes, it is not possible only, but I'm taking, yes, it is possible. And if I can prove that B equal to C, it means it becomes unique only. Correct, right? If I can say I'm taking that there are two different matrices B and C which is inverse of A, and later I'm going to prove that B and C are coming as equal, it means actually B and C are not different but a single matrix. Okay, let me try that. What's the meaning of inverse? It means that AB equals to BA equals to I, equation number 1, and AC equals to CA equals to I is my equation number 2. Okay, let's write now. So B equals to, can I write this as IB? Can I write B as IB? Yes, it's the same thing. Now for I, can I write, for I can write this as, please check, I can write I as CA from here. Please check. I'm writing the value of I as CA. I'm writing the value of I as CA from equation number 2. From equation number 2. Okay, I value as CA. Great. Now I'm going to use the property of associative law in multiplication. C as it is and multiply AB together. Multiply AB together. If Bn is inverse, okay, it means AB has to be equal to I. So I can write this as B equals to C times of I. It means simply equals to C. What I'm getting? I'm getting matrix B equals to matrix C. Hence, therefore, inverse of A is unique. Inverse of A is unique. Correct? Inverse of A is unique. This is clear. 45 question number, inverse of A is unique. Done. 45 is done. Question number 46 now. I took two inverse B and C and I proved them equal. It means actually they are not two different matrices, they are the same matrix. Okay. Again, this is a homework. Please solve it. Why I am giving you the homework? Because it's simply multiplication of A into A. Cannot do that. 2 0 1 2 1 3 1 minus 1 0. Same thing. 2 0 1 2, 1, 3, 1 minus 1, 0. Okay. Multiply this, you'll have row to column 4, 0, 1, which is 5, 4, 0 and 1, which is 5, and last will be again next one 0, 0, minus 1. Okay, 2 into 0 is 0, 0 into 1 is again gone as 0, 1 into minus 1 is 1, 2 into 1 is 2, this is 0, this is 0, so we get 2. Now please find other elements also. You get the value of a square, same way you're going to find what, 5a also, multiply 5 with all the elements. Okay, so we have here 10, 0, 5, 10, 5, 15, 5 minus 5 and 0, that's my 5a. Use this and plus 6i. What is 6i? 6i is nothing but 6, 6, 6, 0, 0, 0, 0, 0, 0. Solve this, find this and get the value using this expression. Have the final answer and comment below. If you can write it, comment. You can check through the online resource also whether it is coming right or not. Please cross check, okay? So please solve the question number 46. This is the last question of the matrix. Let's move on to determinants now. Here also properties are very, very important. Properties are very important. Even the PYQs are asked on the properties in the boards directly. Okay? So do not worry. I understand this is your unit test, but they are preparing for our boards also, right? So from this chapter, we want everything to be covered. The question also can be framed on the PYQ sections as well. That's why I'm telling you properties are very, very, very important. Minor of minus 4. Minor of minus 4. This element 0. Option is D. If they were cofactor also doesn't matter because it's going to be simply 0 only. Okay. 48. Cofactor of 4. In this case things will change. 4, what is the element? A to 1. 2 plus 1 is odd. It means the value minus 2 you're going to take, put with the minus sign outside. You're going to take a minus 2 value, but with the minus sign outside. It will become what? 2. Answer will be option C. Remember the formula of cofactor. Aij is given by minus 1 power I plus j, okay, times of mij, times of mij. Minor of ij. Minor of this term is minus 2 and the 2 plus 1 is odd, that's why there is a minus sign over here. Answer is 2. Answer is option C, 2. I wrote D, my mistake. Please cross check. I hope I have not written this kind of a mistake in other places also. Option is C, right? Option is C. Question number 48, option is C. 49. If A equals to 2, 3, 1, 4, then adjoint of A is what? Adjoint of A is what? How do you find adjoint? Adjoint is simply what? In case of this matrix, transpose these two, 4 here, 2 here, okay, and sign change of these two, minus 3 and minus 1. If it was a subjective question, we'll have a different approach. If it was a subjective question, we'll have a different approach. But in the case of objective question MCQs, we can go like this method. What is the method? Method is, if this is the matrix A, right, and looking to find the adjoint, no? So let's say this element is A11, A12, A21 and A22. Across these two elements, right, you're gonna swap the elements, and across these two you're gonna have what? Sign change. Sign change. Only sign change across the other elements, and across diagonal you're gonna swap the elements. So A12 will become A22 and this will be A11 over here. Got it? This is for 2 cross 2 matrix only. This is for only 2 cross 2 matrix. Finding adjoint. Okay. So option is what? Please check. 4 minus 3 minus 1, 2. Option D is correct, right? Option D is correct. Excuse me. Option D is correct. 49. 50. If A be a non-singular matrix of order 3, then adjoint of this will be what? Remember, we just learned right now determinant of 1, determinant of A power n minus 1. So n is what? 3 over here. 3 minus 1, how much is that? Square. I just taught you the property. Okay. So option B is correct. The property is determinant of A power n minus 1. In this case n is 3, right? Order is 3. So 3 minus 1 is 2. Okay. 50 is done. 51 now. Yeah. So MCQs, if you know the properties, it's very, very fast. You can just look at the question and get the answer. A is 3 cross 3 matrix. Determinant of A is 5. Same thing. Determinant of A power 3 cross 3, right, means 2. Excuse me. 2, so I get 5, sorry, it's a mistake, yeah, I'll become 5 square, right? Determinant of A is 5, so 5 square is 25, option B is correct. Same property, very useful. This property is asked a lot of times, okay? A is 3 cross 3 matrix, adjoint of A is 36, find the determinant of A. From here what we know, it will come out as determinant of A, order 3 means 3 minus 1, so 2 equals to 36. From here we get, this is equals to root of 36, it means plus minus 6. Option C is correct. Option C is correct. Option C is correct. 53 now. If A is a square matrix of order n, then adjoint of A is what? Same property. A. Property itself. Explain this property, right? Remember? Determinant of A power n minus 1. If you have here only one adjoint, if you have, let's say, two adjoint, if you have adjoint of A, determinant, you'll have the answer as A power, determinant of A power n minus 1, the square. If you have two adjoint over here, no? This is two adjoints. That's why the power is 2 over here. If you have 3 adjoint, power will become 3 and so on. Okay? But in this case, only this is valid. Option A is correct. Okay? Option A is correct. 54 now. 3x, x1, 3, 2, 4, 1, find the value of x. Okay? Multiply 3 into 1 is 3 minus x square. 3 into 1 is 3 minus 8. What I get? 3 minus x square equals to minus 5. 3 plus 5 equals to x square. This on this side, this on this side. I get x square equals to 8. It means x equals to plus minus root 8. It means plus minus 2 root 2 is my value of, value of x. D. That simple. Do not think that, sir, 3 is 3, x means 2. No. 3 is here, sir, x is, so 3 is here, sir, x is 2, sir, here this is also 1, sir. They have given you like this to confuse you. 3x, x1, 3, 2, 4, 1. They have given you, sir, this is 3, this is 1. Sir, it means this is x has to be 2, sir, or 4, sir. Wrong, sir. That is only true if you have matrices. If you had matrices, no, 3x, x1, then they'll give you this as 3, 2, 2, 1. In the case of matrix, the elements are same at corresponding places, but not in the case of determinant. There's a difference, okay? Do not make this mistake. 3 and 3 is okay. 1 and 1 is okay, sir, so x is 2. No. X is not equal to 2. X is not equal to 2. Getting it? So please be careful about this. I'm going to erase this now. Not required for the question. I'm going to erase this. Corresponding element property comes only in the case of square matrices. In the case of square matrices, or basically in the case of matrices, not in the determinant. Clear? Now what not to do is also very important. 55 now. Find the values of x for which same condition, x square minus 36 equals to 36 minus 36, right? 6 into 6 and 18 into 2, 36 minus 36. 0. This moves over here. X is either plus or minus 6. X is either plus or minus 6. It's a PYQ from March 2020 paper. Okay? March 2020 paper. Plus minus 6 is the value of x. Done? Simple question. 56 now. If A and B are invertible matrices, then which of the following is not correct? Which of the following is not correct? Okay? Invertible means, of course, both have to be non-singular. This is true property. This is not right. Okay? So excuse me, I have marked it. I should not mark it, right? Yeah. You're looking for incorrect statement. You're looking for incorrect statement, and the correct choice is option A. The correct choice is option A. Incorrect statement is option A, because actually the property is this. You should have determinant of A times I. The answer is determinant of A times I actually. A adjoint A is equals to basically determinant of A times I. It's a property of determinant. Okay? You have to remember this. Not A times I. Determinant of A times I. Okay? That's your property. That's why option A is the wrong statement but correct choice. Okay? 57 now. If A is this, is singular, then the value of x is what? Okay. Find the determinant across this. Singular means what? Determinant of A will be equal to 0. Find across 1, we get x minus 2 minus 1, x minus 2 minus 1, okay, and across minus 2 what I get? This is cancelled, I get 1 minus x, 1 minus x, and across this I get what? I get 1 minus x times of x minus 2, okay, equal to 0. Please check. I have here x minus 3 minus 2 plus 2x minus 2 plus 2x, okay, and over here I am getting what? Minus 1 minus x square plus 2x equal to 0. So we have over here 3x minus 5, 2x plus x is 3x minus 5, and over here I get minus 1 plus x square minus 2x, okay. I'm getting here, please check, x square, 2x and 3x will become simply plus x, and minus 5 minus 1, which is simply minus 6, is 0. Factors, okay, factors will be x plus 3 and x minus 2 as 0. Have a look. Factorize it. Okay, factorize this quadratic. You will have x plus 3 and x minus 2. If you want cross check, x into x is x square, x into minus 2 is minus 2x, and plus 3x will become plus x, okay, and 3 into minus 2 is minus 6. Expand it to cross check. Expand it to cross check. If you want, you can simply break this as 3x and 2x also to get the answer, okay. From here I am getting the value of x as 2 and minus 3. Minus 3 is not there, only 2 is there, means option A is correct. X value is 2 or minus 3. We don't have minus 3 in this given options, so option A is correct as 2. Question number 57 is also over. Okay, 58 now. The inverse of the matrix 2, 2, 4, 3 is what? To find inverse, what we need first? Determinant. Cross check. 3 into 2 is how much? 6. Minus 4 into 2 is how much? 8. So minus 2. Non-zero, good enough. Now let's find the adjoint of A. How do you find this? I told you interchange this. So 3, 2, and this will be sign change. So minus 2 and minus 4. Minus 2 and minus 4. Divide that by. So you want the inverse. You get what? Adjoint of A by determinant of A. I get the answer as minus 3 by 2 actually. Okay, I can keep it outside, right? Yeah. I can keep it outside. I want to do that. I'm going to do that. Minus 1 by 2. We have 3 minus 2 minus 4 and 2. Take the minus sign inside. Take the minus sign inside actually. So you'll have 1 by 2 minus 3, 2, 4 and minus 2. Minus 3 minus 2, minus 3 minus 2, 4 and 2. Option B is correct. Please check. Option B is the correct choice. Option B is the correct choice. Have a look. 58 is done. Question number 58 is over. 59 now. Area of the triangle is 4 square units with vertices as k 0, 4, 0 and 0, 2. Then the value of k is what? Area of triangle means, remember your triangle means, what is it, sir? We have determinant property. 1 by 2 determinant we find with the coordinates k 0, 1, 4, 0, 1, 0, 2, 1. Why 1, 1? Third coordinate is gone, right? Because it is as an area. So there is no volume over here. Equals to plus minus 4. Because area, whether even if it was minus 4, no, area will be taken as positive only. That's why when we are taking the value of area as 4 square unit, I have to consider both the plus and minus signs. Okay. Take this 2 on this side. I get here. Find across this, no, the second column. We get here minus plus minus, so we get here minus 2. This is cancelled. We get k minus 4 equals to plus minus 8. Okay. I'm getting here minus 2k plus 8 equals to plus minus 8. Have a look. I get minus 2k plus 8 equals to plus 8. So 8 and 8 cancel. I get the value of k as 0. Second case, minus 2k plus 8 equals to minus 8, right? Plus and minus 8. I'm taking one case at a time. Plus 8 and minus 8. Bring on this side, I get minus 2k equals to minus 16. So k equals to 8. My values are 0 and 8. Option C is correct. Option C is correct. Have a look. Both the cases, plus and minus 8, right? Taken at a time, one at a time. 0 and 8. Got it? 59 is easy, very simple. 60. Where will you get all these questions? You have to solve all of them. Okay, I'm close to solving 60 questions now. You have to download the class notes and solve all these questions again. Have doubts, come in the live and ask your doubts and get it cleared. Get out of out marks in your unit test. Okay. Statement 1 is given as A is 1 to 1, 1 to 1 and 0 1 1. The singular matrix. We know that if you want, you can find the determinant or simply check here. Whenever you have 2 rows or 2 columns same, answer for that matrix is always 0. If you want, you can find the matrix, you'll have the answer. Again, you find the determinant, you'll get the answer as 0 only. Okay, find across first row, first column, anything you want to do, get the answer as 0 only, you'll get always. But if you want to know the trick, please check 1 to 1 and 1 to 1. Whenever you have 2 row common or 2 column common, it means, or basically same, it means determinant is 0, sir. Determinant is always 0, sir. Okay, singular means what? Same thing, right? Determinant is equal to 0. Check here. Statement 2 says A is a square matrix, A is said to be singular if, yeah, correct, no? Determinant of A is 0. So answer is true, true and correct, and not a correct explanation. No, that is wrong. B, you check. 1 is true, 2 is true and 2 is correct. Yeah, option B is correct. So both the statements are correct and statement number 2 explains statement number 1 correctly. Okay, so answer is B actually. Answer is B actually. Okay, 60 is done. 61 now. Statement number 1, if A is a square matrix of order 2 and determinant of A is 7, then 4A equal to 1 1 2. There is a property for this. Whenever you have, let's say, okay, in this case we have 4A, right? This will become what? 4 power n times of determinant of A. 4 power n times of determinant of A. 4 power n means order is 2 here, right? So right here 4 power 2 times determinant of A is how much? 7. So right here A only. 16 into 7. 7 6 are 42, carries 4. 7 into 7 into 1 is 7 plus 4 is 11. This is correct. This is correct. Property is, if you have 4A, no, it will become simply 4 power n is the order times determinant of A. Yeah, same property. Lambda A, lambda power n times A. Correct. Both are true. Option C is correct. If you had an option over here as statement 2 explains statement number 1 correctly, you're going to choose that option. Statement 2 explains statement number 1 correctly. Okay, 61 is done. 62 now. If A is a square matrix of order 3 and determinant of A is 5, the value of 2A dash is what? 2A dash, determinant. In determinant, what happens is, this transpose or not transpose does not make any difference in the determinant value. Okay, so this will remain as it is, 2 power n. This will be like this. It will remain as it is. 2 power n means what is the order here? 3. So 2 power 3, simply determinant of A. 2 power 3 means 8. This is going to be 5. So we have 8 times of 5, which is 40. Option is D. Okay, does not matter. Okay, A dash transpose or A dash determinant or A determinant remains same. Don't even think a single word is going to minus 40 something else. No, always same. Always same in the case of determinant, whether you take transpose or not. Okay, 62 is done. 63 now. Find the equation of the line joining the points 3 1 9 3 using determinants. Okay, there's a point over here 3 1 9 3. Let's take a point on this as xy. On this as xy. Okay, to find the equation using determinant. So if you find the area of this line, area of this 3 points, if you find, it will come as 0 because it is collinear. Do it. Xy 1 3 1 1 9 3 1. This should be equal to what? 0. This should be equal to what? 0. Let's do it. We get from x what? 1 into 1 is 1. So 1 minus 3. For y we get what? Minus y. We get 3 minus 9. We get 3 minus 9. And for 1 we get what? Plus 1. We get 9 minus 9, which is 0. Correct, na? 3 into 3 is 9 and into 1 is 9. 0. Please cross check. I'm getting here minus 2x and minus y times of minus 6 equal to 0. So I'm getting here minus 2x plus 6y is 0. Do one thing, take minus 2 common, I get x minus 3y is 0. Take minus 2 on this side, I get x minus 3y, excuse me, okay, x minus 3y actually as it. That's my equation. That's my equation of the line on the 2 points given for this. Okay, equation of the line joining the given 2 points is x minus 3y equal to 0. X minus 3y equal to 0. Basically x is 3 times of y. X is 3 times of y. Please check, y is 1, x is 3, y is 3, x is 9. Question number 63 is also done. 63 is over. 64 now. Question number 64 now. Solve the system of equations 2x plus 5y equals to 1, 3x plus 2y equal to 7 using matrix method. Okay. So first find the matrix order. We get 2, we get 5, we get 3, we get 2, we have x and y, and we have this equals to 1 and 7. First thing is to find what? First thing is to find the your determinant of this matrix. This is your matrix X, this is matrix X, A, X, and this is the matrix B. Okay, matrix B. Let's find the A first. So we get A determinant value as 4 minus 15, right? 4 minus, how much is that? Minus 11, which is not equal to 0. So non-singular. It is a non-singular matrix. Let's find the adjoint first. So adjoint of A will find. So inverse this, swap these numbers. They are same 2, 2, and sign change for this minus 5 and minus 3. Okay. So inverse will become what? Inverse of A will become minus 1 by 11, and we have 2 minus 5, minus 3 and 2. Okay. Now you want to find the value of x, right? So you're going to do what? Inverse of A times of B. That's the matrix method. That's the solving a system of equations using matrix method. Okay. A inverse times B. Let's do that. What is A inverse? Minus 1 by 11, 2 minus 5, minus 3 and 2. What is B value? 1 and 7. Multiply them. 2 into 1 is 2, minus 35, right? 7 into 5 is 35. Minus 3 into 1 is minus 3. 2 into 7 is 14. Okay, 14. What I get? Minus 1 by 11. This is going to be minus 33. This is going to be 11. Okay. Solve it. Multiply this number outside to the numbers inside. I get here first term will become 3. This will be minus 1. That's my matrix X. What is matrix X, dear? X comma Y. So my value of X is what? X is 3 and Y is minus 1. So whatever is the matrix given to you, whether 2 cross 2, 3 cross 3, the approach remains same. The approach remains same. Okay. What you do over here is simply find the inverse and multiply inverse to B. That's all. But before all of that, check for the non-singularity. Check for the non-singularity. 64 is done, right? 64 is over. Okay. So 65 now. Now for 65 again, we had to find out A and B is given. We are supposed to use this property and verify. This is a property, right? We're supposed to prove AB inverse is equals to B inverse A inverse. For that I found A inverse first. How do you find that? Check here. 5 into 3 is 15 and 7 into 2 is 14. The determinant of A is coming as 1. 5 is 15 and 7 2 is 14. Determinant of A is 1. So basically adjoint will be same as inverse. 5 and 3 is swapped and 7 becomes minus 7. 2 becomes minus 2. That's my inverse of A. Same way, find inverse of B also. Find the inverse of B also. Okay. 9 6 is 54. 8 7 is 56. Difference will become what? Determinant of B will be minus 2. 54 minus 56 is minus 2. That's why divided by 1 by minus 2. Solve these numbers 9 6 and change the sign of 8 7. So minus 8 minus 7. Minus 8 minus 7. Bring the 2 inside. We get minus 9 by 2 4, minus 7 by 2 and minus 3. Okay. Multiply these two. Multiply this with this. When you do that, you're going to get minus 61 by 2, 87 by 2. Check it out. Minus 9 by 2 into 5 becomes minus 45 by 2, and we have 4 into minus 2. We get minus 8. Minus 8 into 2 is minus 16. That becomes 61. Minus 45 into plus 16 is what? Minus 45 minus 16 will be what? Minus 61. If you're not sure, do one thing, pause the video, do your own calculations. Okay, I've done that just to save some time. B inverse A inverse is over here. Same way, find the product of A and B from here. 3 into 6, 7 into 7, you get 67, and so on. You get the value of AB over here. Check the determinant, is going to come as -2. Find the adjoint, find the AB inverse, you're going to get this value same. It's a property, okay? 65 is done. 66 now, let's start. So 66 question, they have not given the equation to us. You have to form the equations, then we're going to solve it. So I'm going to give you the formation of the equations, then you have to solve and get the answer from your side and give me the answer in comment section. Okay, so let me just form the equations for all of you first. Sum of the three numbers is 6. It means x plus y plus z is 6. X plus y plus z is 6. First thing is given in the first statement. If you multiply the third number by 3, it means 3 times of z, and add the second number to it, means plus y. Okay, we get 11. Means this is equals to 11. Basically I have 0 times of x plus y plus 3z equals to 11. 3 times of third number plus the second number becomes 11. So 0x plus y plus 3z is 11. Second equation is also done. Next is what? By adding first and third numbers, so x plus z, we get double the second number equal to 2y. Double the second number. When you add first and third, double the second number, move on this side, we get x minus 2y plus z equal to 0. Now let's form this. So we have equation 1 over here, equation 2 and equation 3. I'm going to form the matrix form first. Have a look. So we have 1, 1, 1. Okay. Over here we have 0, 1 and 3. Over here we have 1 minus 2 and 1. That's my matrix A actually. Excuse me. That's my matrix A actually. This is my x, y and z. Okay. Equals to what? 6, 11 and 0. 6, 11 and 0. Okay. So this is my matrix A, this is x and this is B. To find x, what are you going to do? Inverse of A times B. How to find inverse of A? For that you'll need, of course, you have to check for determinant first. Should be non-zero. And for adjoint, I'm going to give you a trick. For adjoint, I'm going to give you a trick. Okay, the trick is very simple. What's the trick, sir? The trick is to write this matrix again. This is for adjoint, okay? This is to find the adjoint. I've taught you this already, but since we are learning it over here, revising over here, I'm going to do it again, okay? To find adjoint, just write the matrix once again. 1, 1, 1, okay? 0, 1, 3, 1 minus 2 and 1. Same thing, you're going to repeat the first two columns, so first two rows, so 1, 1, 1, 0, 1 and 3, and then next is to repeat the first two rows, first two columns. First you repeated the first two rows, 1, 1, 1, 0, 1, 3. Next is to repeat the columns. So we get here 1, 0, 1, 1 and 0. Over here we get 1, 1, minus 2, 1 and 1. This part is clear. Right now we have 5 cross 5 matrix. We have 5 cross 5 matrix. Okay. In this, remove the first row and first column. Remove the first row and first column. Now try to find the adjoint directly. Simply you're going to find the directly adjoint. I'll show you the steps. Have a look. So multiply these two. Excuse me. Multiply these two. Vertical form. 1 into 1 minus 3 into minus 2. How much is that? Minus 6 becomes plus 6. So 6 plus 1 is 7. That's my first element. 1 into 1 is 1 plus 6 is 7. Again go here. Minus 2 minus 1. So minus 3. So go in the vertical way and get the answer in the horizontal row. Okay. We get minus 2 and minus 1, which is minus 3. Again 1 into 3 is 3 minus 1. So 2. 3 minus 1 is 2. Same way. 3 into 1 is 3. 1 into 0 is 0. So simply 3. We get 1 into 1 is 1. 1 into 1 is 1. So that is 0. We get here 1 into 0 is 0. 3 into 1 is 3. So we get 0 minus 3 is simply minus 3. That's the second row. Third row will be 0 into minus 2 is 0. 1 into 1 is 1. So minus 1. 1 into 1 is 1 and minus 2 will become plus 2. So 3. And we have 1 into 1. This is 0. So 1. That's my adjoint. Okay. So I've given you a trick to find adjoint quickly in 3 cross 3 case. That's my adjoint. Find the determinant value. Find inverse from here. Determinant adjoint by determinant. Use x equals to multiplication of that inverse with b to get the final answer. Give me the answer in the comment section, please. Please check. I hope this is all clear to you. How I form the equation, okay, how I got this result. I hope this is all clear. Again, same approach, right? You can form the equations one more time here. 2, 2, 3. We have 1 minus 2 and 1, 3 minus 4 and minus 2. That's my matrix A. Here we have x, y and z. And this is equals to what? First is 4 minus 4 and 3. This is the matrix A. This is the x. This is the, what is it? B. So find x, we get what? A inverse times of B. To find A inverse, check for determinant first. Non-zero should come. And then find the A inverse, and that you multiply with B. Okay? What is A inverse going to be? Adjoint of A by determinant of A. Already taught you how to find adjoint in the case of 3 cross 3 matrix. Homework, comment your answer, okay? Comment x equals to what, y equals to what, and z equals to what in the question number 67 and 66, okay? Give me the answer in the comment section for both the questions. This is clear? This is clear also? Very simple. Let's move on now. Okay, so next we have the last chapter of the day today, continuity and differentiability. Do not worry if you want me to do more chapters, if you want me to do different more type of questions, let me know that in the comment section. I'll incorporate those doubts, those questions in the live session, okay? So it's very important for you to watch the entire video and of course, give me your feedback that what do you want from me, okay? Let's start what we have. So I'm going to solve some basic questions on the properties of continuity and differentiability. Okay, and then we'll move on to solve some differentiations on whether it is implicit function, whether it is some formula based of logarithms, exponential. We'll see all of that. Okay, so we'll cover up basically in the session. We'll cover up properties based question, properties based questions on both continuity and of course in differentiability also, okay, on differentiability also, and there will be some question on the definition also. I think 1 or 2 questions I've taken on definition of continuity and definition of differentiability, okay. Now there will be question on derivatives, of course differentiation formulas, where I'm gonna use the functions. I'm gonna use the functions of what? I'm gonna use logarithms, logs, exponentials, and of course I'm going to use ITFs also. So these 3 functions are majorly used, okay. Of course there will be polynomials, but yeah, these 3 functions are majorly used in the question that I've taken. And lastly, also I've incorporated derivative of implicit functions, okay. Implicit function. What's the meaning of implicit function? Those functions where the subject is not clearly given to you. Means usually when you see an equation or function, right, you have y equal to something. But in such type of function, you will not have any subject as y or x, okay. So you have to solve it like this only, okay. So we're gonna discuss all of this in the session today. So let's continue and solve our questions. If you have something else to add, leave that in the comment section. Please do it. It's a request, and that's how we can make the most of it of this revision session. The greatest integer function defined by fx equals to gif of x is what? Okay. Is it continuous but not differentiable? Okay, is it continuous and differentiable? So there are 4 options given to us. I'll just draw the graph and I hope you can see from there. Okay, so this is your graph of GIF. It's continuous over here. There's an open bracket over here, closed, open, closed, open, open, closed, open, closed. As you can see clearly over here, the function is it continuous? No. If I take any integer, for example, let's say x equals to 1, okay, my right hand limit, what is my RHL? RHL is nothing but this value 1, okay, this value is 1. So RHL is coming out as 1, whereas my LHL, if I go from this side, okay, my left hand limit is coming equals to 0. If I approach the number 1 on the number line on the graph from the left hand side, the graph value is actually on the x-axis, right? Means y value is 0. So left hand limit is 0, right hand limit is 1. So we can say that left hand limit is not equal to right hand limit. What it means? It means that limit does not exist. What it means? It means that the given function is not continuous, and we know if a given function is not continuous, it means simply it is non-differentiable also. It means it is non-differentiable as well. I hope you get the chronology. Okay, how did we go? First we said that LHL RHL is not equal. Even at a 1 point, it means in the entire domain it will not be continuous. Not continuous means non-differentiable. Is that clear? Okay, so option D is correct. No, discontinuous and non-differentiable at the point 1. Okay, at the point 1. So D is correct. Option is D. Clear? Very simple. Okay, so let's move on. Question number 69. Question number 69. Which one of the following is not true? Every polynomial function is continuous. Of course it is, right? It is of course continuous always. Every rational function is continuous. Okay, yes, because if you might think like this, y equals to 1 by x, if you see the graph of this function, the graph is this, the graph is this. So sir, of course this is not continuous at this point, no? But this point 0, this x equal to 0 is not part of domain, not part of domain. If one of you are thinking in this way that sir, x equal to 0, the given graph y equal to 1 by x is not actually continuous, but we don't have to check there because x equal to 0 is not part of the domain. How do you write the domain of this function? This function's domain will be given by all real numbers except for 0. All real number except for 0. So 0 is not part of the domain, that's why we don't have to check the continuity at that point. Okay, only in the domain if you check everywhere on the right of 0 it is continuous, even on the left side it is continuous, there is no break in the curve. Okay, hence even the rational function is continuous. Let's move on to third point. Every differentiable function is continuous. Correct? No? Whichever function we can differentiate, it has to be continuous. Otherwise, if it was not continuous, then cannot be differentiated. Okay, every continuous function is differentiable. Not always, of course, not always. Think about it. My favorite example, modulus graph. Okay, y equals to mod of x. This curve is at this point. What is it? It's continuous, sir. It is continuous, but non-differentiable. Non-differentiable because of the sharp corner. Okay, because of the sharp corner. This is my favorite curve. You can see from here. It means the option which is not true is option D. Not every function which is continuous will be differentiable. So option D is my correct choice, but statement is incorrect. Okay, so option D is the choice that we have to make. 70th question now, question number 70. Now we are moving to the world of derivatives, differentiation. Let's differentiate. Y equal to sine inverse of x, the sine inverse of root of 1 minus x square, then dy by dx is what? Then dy by dx is what? Okay, differentiate it. This is nothing but, we can also write this as y dash, right? I hope you all know that. dy by dx is same as y dash. So let's find that y dash. For this sine inverse, we have formula 1 upon root of 1 minus x square. Okay, what about this? Same approach will be there. 1 upon root of 1 minus square of this root. Okay, so 1 minus x square. Right, this value's square, no? See, over here we had x, that's why we had x square. In this case we have 1 minus x square in the root. If you take the root value as a square, means the root will be cancelled, right? Yes. If you take a square of this value, what will happen? Root will be cancelled, no? So you'll have only 1 minus x square left. I hope this is okay. Now I have differentiated for sine inverse, but I have to apply chain rule in this kind of questions. Okay, so differentiate now the root. Differentiate now this root. This root represents what? It represents 1 minus x square. Sorry, one mistake. 1 minus x square power 1 by 2. Differentiating means it will become 1 by 2, 1 minus x square power 1 by 2 minus 1. Okay, it means 1 by 2 will come, 1 by 2 will come, and this value of 1 minus x square will come as the power with minus 1 by 2. It will become 1 by 2 minus 1 is minus 1 by 2. Hence that value will come in the reciprocal, right? It will come in the denominator with the same thing. Power 1 by 2 means the root. So 1 minus x square. Is it over now? Not yet, because you have done for sine inverse, you have done for 1 minus x square, but you have to also do for, basically you have done for the power 1 by 2, you have to do one more time derivative for the number 1 minus x square. Okay, so for that what are you going to get? You will have 1 as 0. This will become minus 2x. X square will be minus 2x, and not in the denominator, okay, in the numerator. Every time you take in the chain rule, the derivative is done in the numerator, not in the denominator, okay. This denominator is coming because of the rule over here. I hope this is very, very clear, okay. Alright, let's simplify. So we have y dash equals to 1 upon root of 1 minus x square plus, okay, there's a minus sign, right, minus 2x comes here, so it becomes minus 2x, okay, divided by this 2 is there, right, so write this 2, and we have over here in this root what we have, 1 minus 1 plus x square, and we have one more root, 1 minus x square. Have a look, 1 and 1 is cancelled, 2 and 2 is cancelled, okay, and we have one more time the last step. We get over here minus x upon this square root of x square will be simply x. We have 1 minus x square as it is. This x and x also cancelled. Square root of x square is simply x. Now check what we have. We have this same thing, right? 1 upon root of 1 minus x square, 1 upon root of 1 minus x square. The result will be what? 0. Will be 0. Option C is correct. Option C is right. Have a look. Fun question. Yeah, we used maybe a little bit of chain rule, but apart from that it is very, very simple, okay. So option C is correct. Please, I have not skipped any of the steps, so please go through every single step that I have written over here, okay. If you are not able to follow it, do one thing, pause the video and look at the steps one more time, and again try to solve from your end, okay. Again, you can get the class notes in the WhatsApp channel, so join right now and get your class notes. 70 is done. Question number 71. Cos inverse of sin x. We are looking for derivative one more time. Let's find it. So I can write here as y dash, okay. Cos inverse derivative. There is a formula. You put minus sign in the numerator. Where will you get all the formulas, dear? Open NCERT summary. You go to this chapter. You'll get all the formulas at one place. Please revise from there, okay. It's very important, and that's more than enough for your preparation for unit test, okay. So differentiate this. You'll get what? Minus 1 upon the formula for cos inverse of, let's say, x derivative is given by minus 1 upon same what you had for sine, okay. So minus 1 upon root of 1 minus, in this case we have not x, we have sin x. We have formula is x square, but in this case we have sin x. We'll write sin square x, okay. And of course, is it over, sir? No, we have to do the chain rule, right? So function which is inside sine will become cos, derivative of sine, derivative of, I'll write for all of you, chain rule, okay. Continue. We get over here minus 1 upon, have a look, 1 minus sine square is nothing but cos square x. This will become what? d by dx of sine will be cos x, okay. You can see here minus 1 upon root of cos square will be simply cos x into cos x. Again, I'm not skipping any step. I can, but I want you to not have any confusion. Answer is simply minus 1. Answer is simply minus 1. Please check. Option D is correct. Option D is correct. Option D is correct. Have a look, okay. This is the formula of derivative of cos inverse of x. So I want to give you the formulas wherever it is required, of course. Now we have a function given. This is exponential function, this is a polynomial function, and this is a constant function. Yes or no? A power x, I'll write the function one again. A power x is exponential, right? Constant to variable power. X power a is a polynomial function, variable power to constant base, okay. And we have, constant power, okay. And we have a power a as a constant. We are looking for derivative. We are looking for derivative. This is then, okay. Not then, then. A derivative, how do you find that? Again, y dash. A power x will become what? A power x will become what? It will become simply a power x ln a. Ln a, yes, not anything else, ln a only, not log, okay. Whenever you have a power x, no, and you're looking for derivative, the formula is simply a power x remains as it is, and ln a comes. Ln a comes. If you have a case of e power x derivative, what happens here is it becomes e power x, and ln in this case, what is the base? E. So ln e will become simply equal to 1. That's why you have the answer as e power x, okay. We'll have the answer as e power x. Correct, no? Here the base was a, that's why we wrote ln a. Here the base is e. So we wrote ln e, okay. Log of e with the base e is what? Ln represents the base is e, right? So log of e with the base e will be always equal to 1. Hence answer is simply e power x. Make sense to all of you? Okay. Just creating a justification for my formula. Again, this is the rule that we are using over here. So first part is done. Let's move on. This is very simple. You'll get a in the front. You'll have x power of a minus 1, right? Whatever is the power minus 1, and is a constant, so it will be simply 0. Any constant when you differentiate it comes out as 0. Okay. Answer is here a power x ln a plus a times of x power a minus 1. That's my final answer for derivative. I hope this is very, very clear. Clear, right? Okay. So option becomes C, right? Log of a with the base e is simply ln only, right? Log of a with the base e is simply ln. Okay. So answer is option number C. 72 is also done. 72 is also over. 73 now. So please download the class notes and practice these questions. Again, I'm making a request. More than few times I've requested you, because this is very, very important to make the output come out of this particular session. If you watch this long video and you get nothing out of it, then there's no point of me taking the classes. Okay. So if you want me to take more and more sessions of PU2, more and more sessions of PU1, I want the efforts from all of you. Otherwise, there's no point of coming here and just doing the questions and moving on. Of course, I can solve all the questions, but how is this going to benefit you? Only that can happen if you solve all the questions and get whether it is right or not, okay, whether you are improving or not. Okay, it's a whole process. The practice has to come from your side, okay, the dedication has to come from your side. I'm just here to help you out. All right, it's your examination, your results, your preparation of the competitive examination, whether it is CET or JEE. I'm here to just help you, just assist you. Okay, you are the driver, you are the person in control. So please follow my words, have these questions practiced. I'm telling you, this is going to be very, very useful. All the questions. Okay, y equal to sec of tan root x. We are looking for again derivative. This question is very simple, but we'll be using what? Chain rule a lot. We'll see. So let's say y equals to, we have sec tan root x. Okay, I have to differentiate once sec, then I have to differentiate once tan, then root x. So we have to differentiate 3 times, 3 different functions using chain rule, of course. So start from here. We have y dash. Sec will become what? Derivative of sec is, so if you write here derivative of sec theta is nothing but sec theta tan theta. Okay, first formula. All right, second formula is derivative of tan theta. This is nothing but sec square theta. Okay, some formulas I am listing, so just to help you out, So if you please check here, sec will be sec theta. What is this angle over here? Whatever it is there, you're going to write the same thing. Tan of root x in this, and then next is what? Tan theta. So right here, tan of tan root x. Okay, please check if anything makes sense to you right now. So yes sir, we have all the options as the same only. So means so far we don't have any clarity. Okay, now next will come what? Derivative of tan. So what I'll have sec square. Now this time the angle is root x. Okay, any clarity now? Yes sir. So option D is gone, option B is gone, option D and option B is gone. These two are wrong. Okay, correct now? Now is it over? No. Differentiate root x also. So for that you're going to have what? Derivative of x to the power 1 by 2. Whenever you say root, it means power is 1 by 2. So this whole thing will remain as it is. I'll just differentiate this part. I'll have 1 by 2 x power 1 by 2 minus 1. This will become what? This whole thing will continue as 1 by 2, and this root x will come in the denominator, because x power minus 1 by 2 is what? X power minus 1 by 2 means 1 upon x power 1 by 2, and it means 1 upon root x. I know it's very simple, most of you know this, what I'm doing, but even one student is not able to understand that. My job is to explain that person also. Okay, so please be patient if I'm doing something extra. Alright, x power minus 1 by 2 is simply 1 upon x power 1 by 2, which is nothing but 1 upon root x. Okay, so you check here now what is the combination. So we want sec, we want tan, we want sec square, we also want denominator as, this will be denominator, right? 1 by 2 is there, so 1 by 2 root x. So we have only one option as such, option C is correct. Please have a look. Sec of tan root x, tan of tan root x, sec square of root x and 1 upon 2 root x. Clear? Very much clear. Question number 73 is also over. I hope the formula is also visible. Let's move on to question number 74. Okay, now we are using again ITF, cos inverse of e power x. So derivative of cos inverse, I hope you know that already. Yeah, you know that. I have given the formula for cos inverse, right? So right here, y equals to cos inverse of e power x. So I'll have y dash as minus 1 upon root of 1 minus e power x the whole square. Is it over? Of course, the differentiate e power x also, which will be simply e power x. Okay, so I get what? Minus e power x divided by, in the root we have 1 minus e power 2x, because x power 2, right? Power rule can be applied, we have to multiply that, so 2 into x will become simply 2x, so e power 2x. Option B is correct, I think. Minus e power x, 1 minus e power 2x, yeah, option B is correct. Very simple question. See, if you know the formulas, good enough to solve the questions. Okay, all the problems that you can see over here on the screen are from either NCERT or from your PYQ section or your question bank. So nothing is out of the syllabus. Okay, all these problems are relevant to you. If you feel this is very easy, I do not make the questions, it's given by your board, I'm taken here and explaining it to you over here. Okay, so I'm not made the question simpler just to make you feel good. If it is simple, means it is there in your syllabus. Okay, be happy, you're gonna get the marks in the examination if it comes. Okay, that's how it's gonna work. 74 is done. 75 now. Derivative of e power sine inverse x. In this case, exponential function has the preference, so differentiate that right here. Y equal to e power sine inverse of x. First differentiate e function, so y dash will become e power sine inverse of x, because e power anything remains as it is. Remember, e power x remains as e power x, so e power sine inverse of x will remain as e power sine inverse of x. Okay, next will be differentiating this sine inverse. Derivative of sine inverse of x. Continue, e power sine inverse of x, and derivative of this will become what, dear? 1 upon, right, root of 1 minus x square. Anything else is there? No. Okay, so answer is option A, right? Am I right? Yeah, e power sine inverse of x upon root of 1 minus x square, the derivative of sine inverse of x. 76 now. This was a very simple question, all of you. This is a even more simpler than the previous one. Okay, the derivative of f given by fx equal to tan inverse of x exists in which, x equals to which interval. Okay, for x, which interval is validated. So if you remember the curve of your ITF, that's why I keep saying you whenever I teach ITF, the graphs are very important. The graph of tan inverse of x, that's the graph. This is the point actually, yeah. This is the curve, so right, excuse me, doesn't look like the curve properly. I can do better than this. Yeah, so this is the curve. This is my value pi by 2, right? And this is minus pi by 2, and this is all real. Okay, negative infinity to positive infinity, basically all real. Got it? So please check, is the graph always continuous? Yes. Any sharp corner? No. For what value of x? For all the value of x. What it means is simply x belongs to all real number. The graph is continuous and differentiable. So x belongs to which option? Option C. All real, right? So I know many of you got the answer by looking at the curve. But that's what, sometime if you know the definitions, the concept properly, the answers comes very, very quickly. Okay, and that's the way to solve it. There's no other way. Okay, so please try. Otherwise, why would you take more time to solve any question? Okay, if you know the basic definitions, your job is done. So please have a look. This is very simple. 76 is also done. Question number 77 now. Statement based questions. The function fx equals to mod of x is discontinuous at x equals to 0. Oh, that's wrong. That's incorrect. Mod of x, my favorite function. Okay, mod of x, is it discontinuous? No, not possible. X equal to 0 is not discontinuous, sir. It is not discontinuous. Is there a break in the curve? Is there a break in the curve? Tell me all in the comment section. Say no. Give me a comment. No, sir. Y equal to mod x. There is no curve actually. There is no break in the curve. It means this statement is wrong. Wrong actually. Option number 2, function fx is not differentiable. Now that is true because of the sharp corner. Okay, at x equals to 0, okay, what happens is there is a graph consists of sharp corner. Okay, for that reason, cause, because of that reason, what happens is we can't differentiate it. Okay, if you want, I can give you more explanation. This is x, this is minus x. Derivative of x is what? Derivative of, if you want to take RHD, right? RHD will become equal to 1, and if you solve for LHD, what is LHD? Left hand derivative. This will become minus 1. Okay, are they equal? No, sir. LHD is not equal to RHD. Left hand derivative is not equal to right hand derivative. It means non-differentiable. Okay, so LHL and RHL is there for limits. Okay, and we use the same thing for the case of continuity also. But in the case of differentiability, we have LHD and RHD, and they are not equal. This is coming as minus x, right? This curve is minus x, y equal to minus x. This curve is y equal to x. The derivative is 1 and minus 1, not equal, hence non-differentiable. The algebraic understanding of the this whole thing. Otherwise, graph gives me sufficient evidence. We have a sharp corner, means non-differentiable. So this is correct. So answer is 1 is false, 2 is true. 1 is false, option B. 1 is false, 2 is true. Okay, please be careful while picking the right option, because sometimes you know the answer but you end up picking a wrong option. Okay, so statement 1 is false and statement 2 is true. These silly mistakes can happen, that's why it's called silly, right? So please be careful. Question number 77 is done. Question number 88 now. Now this is a very good question. In this question you have to use property of logarithms. Now what is the property? Whenever you see something or two functions multiplied, whenever you see f into g, or you see f power g, or you see f by g, whenever you see these three things, the functions in the form of product, functions in the form of powers or basically index, and functions in the form of division or quotient, whenever you see that, simply apply log on both sides. Apply log on both sides. Okay, and later simply find the derivative. That's the approach for this kind of question. Okay, I'll show you. So whenever you have this kind of operations, what is the first choice? F into g, second is f power g, and third is f by g. Okay, third is f by g. What are you gonna do? You're gonna simply find this as log, take the help of log and find the derivative. In this question, which form we have? We have the second form, x power sin x. X is a polynomial function, sin x is a trigonometric function, and they're in the ratio, they're in the index, okay, not the ratio. Let's solve it. So what did I say? Take the function y equal to, of course, x sin x, and take log on both sides. You're going to get here as log of y equal to, what you'll have? Log of x power sin x. We know all the property, sin x will come in the front. Sin x will come in the front. So you basically function becomes what? The function becomes log y equal to sin x log x. Sin x log x. Now this is my final function, okay? I'm going to apply derivative to this. Apply derivative. Next step is to apply derivative, okay? Let's do that. Differentiate log. What happened to this? 1 by y, okay? And then comes your y dash. Derivative of log is 1 by y. And since it is y, no, differentiate y also. Chain rule, you get derivative of y is y dash. Clear, right? Not a problem. Derivative of log is 1 by y. Derivative of y is y dash. We are looking for y dash only, right? We are looking for derivative only. Differentiate now, you have to use what here? You have to use your product rule. So differentiate sine first, you get here cos x, and keeping the log as it is, plus sign will come. This time keep sin x as it is, and differentiate log, you're going to get what? 1 by x. You're going to get what? 1 by x. I want to make one thing very clear. Whenever I'm writing here log, no, basically I mean that the base is actually e, not the 10 base or not the other bases, okay? Whenever you're in the syllabus you see the log or ln, base is always e. If there is a other base, they'll mention that. There's a mention of that, whether it is 10 or something else, they'll mention that, okay? Now we want to bring this y on this side. So what are you going to get? You'll get y dash equals to y times of cos x log x plus sin x by x. Okay, cos x, it looks like log alpha. I'm going to make that to x actually. This is x. Okay, that's the value is x, and I want to take this y value. What is y value going to be? Simply write that what is given to you, x power sin x. That's my final answer. X power sin x times of cos x log x plus sin x by x. Okay, that's my final answer. That's my final result. Please have a look. Okay, I hope all of this is visible to you. Have a look. This is very, very clear. Question number 78 is very, very clear. Let's move on to question number 79 now. Okay, 79 now. Find dy by dx if y equal to sine of tan inverse of e power minus x. Again, same thing will be there, no? We'll have, so this will be a homework question. This will be your homework question. One question as homework from the derivative also. See, there is no question over here. See, before was 78, this is homework, this is 79, okay? So one extra question I have taken, that is just for your homework from derivatives especially. So differentiate sine first, okay? Take this as some angle and then differentiate this. So first derivative will be acted over here, second derivative will be acted over here, and third derivative will be acted over here. Not I'm saying second order derivative. I'm saying you have to differentiate once with sine, once for tan inverse, one for e power minus x. I'll give you the formula also. Derivative of sine alpha is given by cos alpha. Derivative of tan inverse of something, let's say, I write here tan inverse of, let's say, y is given by what? Will be given by, I'll write this as t actually, some other variable t, given by 1 upon 1 plus t square, and e power x is derivative given as, is given as simply e power x. So we have a minus sign. Let's see if I have a minus sign over here, it will become e power minus x into minus 1, okay? Because e power minus x will remain e power minus x, and then we're going to differentiate minus x, you'll get the value as minus 1. That's why you have minus sign over here. So we have listed all the three formulas, 1, 2 and 3. Use this formula to get the result for the question given to you as homework. And okay, cross check, you can cross check any other online platform. If you're having difficulty, let me know, we'll solve this question also in your live class. Okay, good. 79, dy by dx y equal to e power x square e power x cube plus e power x5. We have differentiating all this, very simple question. So we have to write a derivative of this will become what? E power x. For this you'll have what? E power x square remains as it is. Now differentiate x square. So what are you going to get? 2x, right? No, e power x square times 2x. Great. Derivative of x square is 2x. Same thing, e power x cube, and you have over here 3x square. Okay. Next time will be what? E power x power 5, right? So sorry, e power x power 4, right? So you'll have 4x cube. And next will be what? E power x power 5. You'll have here 5x4, and that's your answer. E power x square 2x, e power x cube 3x square, e power x power 4 4x cube, and e power x power 5 5x power 4. This is your answer. Done. Got it? As simple as that. Question number 80 now. Question number 80. Now this is a very good question. Okay, so write this function as okay, we want f dash only, so let's write it as fx. We're gonna write this as sine inverse. Let's make some changes. 2 power x plus 1 means 2 times of 2 times of 2 power x. 2 power x plus 1 means 2 times of 2 power x. All of you will repeat and understand this. 2 times of 2 power x plus 1 means 2 times of 2 power x. Okay, that's the numerator. Denominator will become what? 1 plus 2 power x the whole square. Okay, got it? Now take the substitution as 2 power x equals to tan theta, equals to tan theta. Have a look. So you'll have here sine inverse of 2 tan theta upon 1 plus tan square theta, 1 plus tan square theta. Luckily for us, there's a formula for this, right? Sine inverse of, formula for this is nothing but sine 2 theta. That's the formula of sine in terms of tan, right? Sine 2 theta equals to 2 tan theta upon 1 plus tan square theta. Great. Okay. So now you have this as f of x. This will become what? Sine inverse of sine will be cancelling each other. We'll have only 2 theta left. So f of x is 2 theta. Okay. Find theta from here. Tan theta is 2 power x. Tan theta is 2 power x. It means theta will become equal to tan inverse of 2 power x. Okay. So we can continue over here. We'll have f of x equals to 2 times of tan inverse of 2 power x. 2 times of tan inverse of 2 power x. Next is derivative. Let's have it. Okay, derivative will be what? We'll have over here f dash of x will be equal to derivative of 2 is a constant, keep it as it is, and tan inverse will become what? 1 upon whatever is the value over here, 1 upon 1 plus 2 power x the square. The formula of tan inverse is what? Formula of tan inverse is, they write it over here, yeah, 1 upon 1 plus t square, same thing I'm using. 1 upon whatever is over here in the tan inverse value, square of that. Is it over? No. Apply chain rule. Differentiate 2 power x also. Differentiate 2 power x also, you're going to get 2 power x as it is, and then comes ln 2. Remember, I've given you the formula for this. A power x derivative is a power x times of ln a. In this case, 2 power x times of ln 2. Simplify this, I'll have f dash of x. Please check 2 power x over here, 2 power 1 over here. I get 2 power x plus 1. Then the product, right? This all is in the numerator is in the product. So I get this as 2 times 2 power x plus 1. Same base, power is added, okay? And of course the other constant ln 2 is there, and the denominator over here 1 plus, I can take the square, right? So 2 square power x. This whole thing will become what? 2 power x plus 1 ln 2 divided by 1 plus 4 power x. This is my f dash of x. F dash of x. And this is my final answer, okay? Have a look. Please have a look. This is my final answer. Question number 80 is also done. Last few questions to go. I hope you had fun so far. I know it was lengthy session, but supposed to be, right, to cover all the syllabus, to cover all type of questions. Okay. Question number 81 now. dy by dx equals to what if y equals to cot inverse of 1 plus sin x? Question looks very difficult, right? But the answer will be very simple. I'll show you. Just one thing. 1 plus sin x no is given by, I can write 1 plus sin x as, 1 second, I can take some more space. Over here. So I think this will work. 1 plus sin x equals to, I can take this as, have a look. 1 can be written as cos square x by 2 plus sin square x by 2. This is the value of only 1, okay? This is just 1. Alright, plus sin x is given by 2 sin x by 2 cos x by 2. So I've written 1 as it is over here, cos square plus sin square, and sin x as 2 sin x by 2 cos x by 2, the double angle or half angle formula, okay? So please check, if I take the root over here, so basically this will become what? This will become cos of x by 2 plus sin of x by 2 the whole square. A square b square 2ab. A square b square 2ab. Formula is a plus b the whole square, okay? Right here 1 plus sin x. This is in the root. So right here 1 plus sin x in the root. Apply the root over here also. This root and this 2 will cancel. This root and this 2 will cancel. So basically this 1 plus root x, 1 plus sin x in the root will become cos x by 2 plus sin x by 2. That's my first equation. Same fashion I can write this as 1 minus sin x in the root will be what? Will be cos of x by 2 minus sin of x by 2. This is my equation number 2. How come minus sin, sir? Because we have minus over here, sin x. This will become minus 2 sin x by 2 cos x by 2. So a square b square minus 2ab. A square b square minus 2ab becomes a minus b the whole square. That's why we have cos x by 2 minus sin x by 2 over here. Second equation. If you use it over here in the equation directly now, y equal to cot inverse, check, sum of these two, cos x by 2 plus sin x by 2, plus sign is there, and we get again for this bracket, for this root we get this value. Second equation, cos x by 2 minus sine x by 2. Numerator is done. Move on to denominator. Same, the difference we have to take this case. So take the difference, cos x by 2 plus sine x by 2. This is a difference, so we are going to put a bracket, okay? And this case will have again same thing, second bracket equation. This is clear, okay? Now have a look. Cancellation, you please pay attention to this. We have sin x and sin x by 2 cancelled. And in this case, we'll have cos x by 2 and cos x by 2 cancelled because there's a minus sign outside, right? So it cancels the cos and cos. Great. Have a look what is left now. Y equal to cot inverse. What's the numerator? It's going to be 2 cos x by 2. 2 cos x by 2. Denominator 2 sin x by 2. Please check. Sin x by 2 and this minus and minus will make what? Will make plus. So plus sin x by 2 becomes 2 sin x by 2. This 2 and 2 is cancelled. I am getting here cot inverse of cos by sin is nothing but cot x by 2. This is my y. Hence the value of y becomes cot inverse of cot. Cancel the effect, simply x by 2. Derivative of y means simply y dash becomes 1 by 2, sir. Derivative of x is what? Derivative of x is 1 and the constant 1 by 2 remains as it is. Derivative of x is 1 and 1 by 2 the constant remains as it is. So we have 1 by 2 into 1, simply answer is 1 by 2. Is the answer simple or not? Question looks difficult, answer is very simple. Got it? This is clear. This is clear or not? It's clear. Okay. Alright. 81 is done. Achha, why is this angle given? Just to make the sign positive. Because when you take the root, no, what happens is we have a plus minus sign. We're taking plus because of the angle in the first quadrant. Angle in the first quadrant. Okay. In the first quadrant. Okay. Let's move on then. Have a look. 0 to pi by 2, right? This is the curve of cos. This is the curve of sine. Okay. The cos will be, yeah, positive and higher also. Got it? That's why there is no sign change over this. Great. So I don't think we need that. Let me erase it. So this is clear. 81 is clear. Question number 82 now. Find all the points of discontinuity of the function f, where f is defined like this. Okay. Great. Number line. We have 2 over here. When 2 is closed and less, right? The function is x cube minus 3. When 2 is open and more, right, is x square plus 1. We know that this is a polynomial function and this also is a polynomial function, right? They are both continuous. Polynomial function is always continuous, okay? Always continuous. This will be a parabola, this will be a cubic curve. Always continuous, okay? So this is both, this also is continuous and this part is also continuous. Now means every point more than 2 and less than 2, the given function is continuous. Okay, we have to worry about only at the point 2. Only at the point 2. Simply find the value. If you find the limit from here, limit if you find at x equals to, at x tends to 2 for the function f. Okay, limiting means you have to use this function. Okay, so use over here x square plus 1, right? Means x square plus 1 when x limit tends to what? When the limit tends to x tends to 2. Okay, we're getting here 2 square plus 1, how much is that? 5. How much is that? 5. So limit is coming out as 5. What about the function value at 2? For this we have to use this function, right? There's a equality over here, please check. There's a equality over here, less than equal to. So f of 2 will become what? We have to use here x cube minus 3. So 2 cube minus 3. 2 cube is what? 8. Minus 3 becomes what? 5. Okay, minus 5. Okay, so basically I'm getting this this equals to the limit, right? The function value is equal to limit at 2. Okay, hence it is continuous at the point 2 also. Now let me continue. Okay, after 2 it is continuous because polynomial. After 2 it is continuous because it is polynomial. Before 2 it is continuous because it is again polynomial. And at 2 it is continuous because we got limit and function value equal. It means in the entire domain for all real numbers, function is everywhere continuous. Okay, everywhere continuous. what happens there? It means there is no point of discontinuity. What are they asking? Find all points of discontinuity. What is the answer? There is no point of discontinuity. What is the answer? No point of discontinuity. That's my final answer. This part is my answer. Why, sir? Because after 2 it is polynomial function, always continuous. Before 2 is a polynomial function, always continuous. And at 2 we got limit value as 5 and function value at 5. It means both are equal, hence continuous at the point 2 also. So in the entire domain, which is all real number, it is everywhere continuous. It means no point of discontinuity. Question number 82 is done. Done. Have a look one more time. Okay, can we continue now? Question number 83. Okay, question number 83 now. So let's go. Determine the value of k if fx is equals to k cos x upon pi minus 2x when x is not equal to pi by 2, and when it is equal to pi by 2 it is simply 3. So basically they have given you function value, excuse me, so this function value at pi by 2, okay, is given as 3. Function value at pi by 2 is given as 3, okay. Alright, sir. And what are they saying? We have to find the limit value. Let's find the limit value. So limit value will be for fx when x tends to pi by 2. We'll find this, and if it is coming equal to, we have to put them equal to 3, right? Because they're saying that is continuous. They're saying it is actually given as continuous. Then only we can find the value of our variable k. Okay, the variable is k over here. We have to find what is this equals to, right? Find the value of k. So let's find that. This will be equal to what? F of pi by 2, which is nothing but 3. Limit is what? Limit will be k cos x upon pi minus 2x limit x tends to pi by 2, x tends to pi by 2 equals to f pi by 2 means 3. So right here 3. That's my limit expression. How do you solve the limit now? Use L'Hopital's rule. L'Hopital's rule. Use it. So you're going to keep the differentiation in the limit, you're going to differentiate under the limit, right? Both numerator and denominator separately. X tends to pi by 2 continues as it is. Differentiate numerator and denominator both separately under the limits, same limits, okay? So k as it is, cos becomes minus sine x. Okay, how about this? This will become 0 and minus 2. Correct now? Have a look. Pi will be 0 and this will become 2 into x is going to be simply minus 2 into 1. Okay, so this minus and minus goes out. This is equal to what? 3. Now substitute the limit, you get k times of sine pi by 2 equal to 3. Sine pi by 2 is what? 1. It means k by 2 equal to 3. This k, okay. From here I am getting k value as 6. From here I am getting k value is 6. Have a look. My answer for k is simply 6. This is done. Question number 83 is over, sir. Question number 84 now. This is simple. I hope all of you got it. The last question of the day, as I said, total I have taken 84 questions. This completes our session today. Okay. So let's solve this and complete our work, our preparation. Anything else you need, you have to put that in the comment section so that I can complete that in the revision, live revision session. Okay. Find the value of a and b such that fx equals to this when x is less than 2. So basically we have two variables and we have 2 points given here. One point is 2, other point is 10. Okay. Let's solve it. So first we're going to use what? At the point 2. At the point x equals to 2. They're saying that it is actually continuous function at both the points. At both the points. Okay. So it means at x equal to 2 what will happen? So limit value of the function when x tends to 2 will be equal to f of 2. Okay. Where's the limit value function? Limit will continue from here, right? So we're going to write this as twice of a plus b equals to f of 2 is what? From here. F of 2 will come from here, so 5. Equation number 1. Okay. Limit of fx at x tends to 2 means what? X will be 2, 2a plus b equals to f of 2 means here we have equality means f of 2 is 5. Okay. My first equation is clear. Okay. Second one, when we take at x equals to 10, same thing, limit of the function fx when x it tends to 10 will be equal to f of 10. Limit, have a look at the limit. Same value we are going to use this function because we have less than symbol over here. So this will become 10a plus b equals to what? F of 10 is what? Check here, we have equality over here. We have equality over here. It means it becomes 21. F of 10 is 21. This is f of 10, 21. Okay. So this is my equation number 2. Equation number 2. Do one thing. Do equation 2 minus equation 1. So right here 10a plus b, and we have over here 2a plus b equals to 21 and 5. Subtract them. Subtract, cancel. I get 10a minus 2a is 8a, and this is what? 21 minus 5, which is 16. So I'm getting a value is 2. Value of a is 2. Use the first equation. We had 2 times of 2 plus b equals to 5. This is from equation number 1. From equation 1, okay? From equation 1. 2 times of a plus b equals to 5, okay? So a is coming as 2 means 2 times of 2 plus b equals to 5. So 4 plus b equals to 5. It means b is equal to 1. So values that you have for the variable a and b is a equal to 2 and b equal to 1. Is that clear? Have a look. All of this is clear? Okay. So this completes the session today on your revision of PU2 unit test, okay, and for mathematics, of course. I hope you had fun. I hope you learned something. Whatever the requirement, you're going to leave that in the comment section, and with this I can end the session today. I'll see you again very soon in the live session of your revision, and in that again we're going to solve more and more questions. We'll revise, we'll take your doubts also there. So please be ready and be on time in the live sessions. You know, we start always on time, and of course that is it for today. I'll see you again very soon. Till then, take care. Bye bye.